Hello, everyone. Hello. Let's get things underway. So, my name is Nicholas Lane, and welcome to Flower AI Summit 2024, Day 2. So, for those who weren't in attendance yesterday, this is a 2-day event. The first day we focused on AI research. So we had an amazing set of speakers and posters that were exploring where federated learning is going and how we can advance the field even further. What I wanted to emphasize to those who are joining today for the first time is that this event, whoops. One second. Yeah, this event that I like to call FS24 has been running now for 4 years. Each year it grows. It grows almost it doubles each year. And so it's now grown to be the world's largest conference in federated learning. We have people joining us from around the world, folks flying in from America, China, parts of Europe. We have had around 17 different speakers and around 20 different posters. It's being broadcast on our YouTube channel, which has grown to now be the largest federated learning YouTube channel on the platform. And so in a field where often you have, on the order of 10, 50, 100 people, we now have over 1,000 registrations to the event. So it's grown by leaps and bounds, and this makes me tremendously excited. The foundation for this, of course, is that although this is a 2-day event, every other day of the year, the foundation comes from each of you, the Flower community. And so equally, the community itself has been growing in leaps and bounds. We now have 120 contributors. So this is folks who every day are building pieces of the ecosystem that we all can use and benefit from. We have in our ecosystem of AI developers and researchers, 3,400. And importantly, there are now 1,200, or actually over 1,200 unique types of FL and explorations of FL that are built directly upon Flower. And so the community's been growing, people have been building, and so that makes me tremendously excited about we're finally reaching a critical juncture of critical mass, because we have this hypothesis that federated learning and related forms of technologies that do things like decentralized AI or privacy-preserving AI will actually take off and start to be widely adopted when we have two main things that are now coming to take place. One is a platform, a set of software tools that are simple to use, and having that combined with an AI community that is engaged in pushing it forward. And once you have those two things, we believe you're going to see both acceleration in the field and rapid adoption. When I look through the list of registrations, I see many of the folks that we saw yesterday, which are top-tier universities using Flower to perform their basic research. And today at AI Industry Day, we're seeing a wide variety of industries interested in being able to use this technology. And they range across the field. People such as Shell, banks, HSBC, healthcare providers, and so on. There's a lot of various types of industries that can have their day-to-day machine learning practices transformed by adopting these styles of approaches. There's also in the room and online big tech firms, some of which who have federated learning methods, looking to how they can also adopt these techniques. And so I'm tremendously excited by the critical mass that's actually starting to build. Let's talk about today. So yesterday was all about research, today's all about development. I'm going to shortly introduce Daniel. Daniel will be giving us a kickoff keynote that is going to be examining how the Flower ecosystem has evolved to improve the way we can do deployments, the way we can examine how We can have these types of technology being used in the real world. But the rest of the day is actually dedicated to this theme in general. And so you're going to see speakers talking about different areas where they're going to see private machine learning being highly important. You're going to see folks talking about best practices that they've learned. You're going to see folks talking about how this technology can help us adhere to things like AI regulation. And so enjoy today, network with each other, and let's see how far we can go. With that, I'd like to introduce Daniel. Daniel is going to talk to you about how Flower is now starting to impact AI industry.
Thank you so much. I can only echo what Nick was saying. It's really fantastic to see how the Flower community has grown, and also beyond the Flower community, the entire field of federated learning and also all approaches like differential privacy and secure aggregation that are related to it and that often get mentioned together. For those of us who are here for the first day, for the first time, so all of us who haven't joined yesterday, I want to take just a few minutes to repeat why we are actually working on this technology and on this community. The natural state of data in the world is distributed. So data is distributed across different organizations, it's distributed across different user devices, and often even within a single organization, data is distributed across different departments. It can be distributed for legal reasons, like data that has to reside in different regions around the world, or maybe just for practicality reasons, large amount of data that get generated by sensors that cannot be easily moved. So AI projects that we do today, most of them, they just operate on a single one of these data partitions. So it's actually quite obvious if you look at it from that perspective that this approach is quite limited. And you could almost say that people are discussing, are you GPU rich or GPU poor? And that's a pretty popular question. But I think the more important question is, are you data rich or data poor? And it's quite obvious that the current way most AI projects work, even large language model trainings, even foundation model trainings, is actually quite data poor if you compare it to the overall amount of data that we have in the world. Now, companies are trying to solve this usually by trying to collect more data. So trying to collect user data from user devices, or trying to partner with other organizations to get access to that data. But it's also quite obvious that this is still fundamentally limited because the amount of licensing deals you can strike with other organizations is also severely limited. Now, federated AI at least has the potential to solve this. It enables us to, instead of having to move the data, we're moving the computation. We're moving the computation to where the data is, and we'll leave the data where it is, and we don't have to move it. And that fundamentally is just such a different approach that it unlocks us to do completely new things. And it's a huge opportunity. This is just shaping up. We're seeing the first of these systems. Some companies are incredibly successful with these systems and can build systems that they weren't able to build before, and thus unlock AI in completely new areas. Now, there's different flavors of federated systems. A typical one that you often hear in the press is a cross-silo federated learning with multiple organizations. So think about multiple hospitals that are collaborating on a model training and that are all contributing their patients' data in an anonymized form often. Another case is cross-device multi-user federated learning. So that's a typical setup for large-scale federations where a single organization deploys some application on mobile devices and then wants to train a model across these mobile devices. Two other flavors of federated learning that often don't get as much attention, but that are bringing a lot of value to some organizations are cross-device single-user federations. An example here could be a factory with multiple sensors. All of these sensors are producing massive amounts of data, And then it's just easier to train a model in a federated way across these different machines. And the last, but definitely not the least, is cross-silo single org, where you have a single organization with data in different silos. For example, a single organization with data in different regions across the world, and they cannot move the data for legal reasons. Now, I mentioned yesterday there's this virtual cycle between research and industry. And yesterday we looked at the research side. Today we're looking at the industry side. Yesterday's announcement included Flower Next. Flower Next comes with a large number of new features like Flower Mods and the low-level messaging API. Flower Next is already available in Flower Nightly. We also announced Flower Tune and a large extension of this, which is called Flower LLMs. And then we also launched the Flower Discuss, which is the new community forum that allows for more permanent and searchable discussions compared to our existing Slack channel. And it complements our existing Slack channel. So join discuss.flower.ai today. What does industry need? Industry needs foremost privacy and security. For larger deployments, we also need scale and performance. So you want these deployments to reach a lot of devices, reach a lot of data partitions, and then also you want these workloads to finish in a short amount of time. And then for ecosystem and integrations, you want these systems to integrate with all of your existing systems. So the current model of Flower, and this ties into what industry requires with Start simulation and with Start server and Start client, you have this one deployment, one run philosophy. Your training executes, and after the training finishes, the whole system shuts down. But can we do something like one deployment, infinite runs? Today we're introducing multi-run. Multi-run is the Flower Next deployment engine. And I'll now, over the next couple of slides, show in a number of steps on how you would build up a production-grade Flower system, federated learning system, that allows multiple researchers and multiple engineers to work on the same set of data without having to restart the entire system again and again. So let's say you have data in the US, and let's say you have another data partition with EU customer data. You would then put this in the US. You would start what Flower Next calls a supernode. You would put the data on a supernode. You would do the same thing for the European data. So you would start that in some European cloud region or on your own infrastructure. And then for these two instances to collaborate, you would start what Flower Next calls a superlink. So that's infrastructure that's sitting there and that can communicate, pretty similar to the existing server and client. But with Flower Next, we're basically unbundling the running gRPC server and the actual application, the strategy that you want to run, the rounds of federated learning you want to do. So if you want to start a workload on this system, you would start what we call a server app. And that server app now has the capability to send messages via the superlink to those supernodes for execution. So let's say it sends the first message to the top supernode, and that would start what we now call a client app on the client side and execute the model training on that supernode. And of course, you also want to send a message to the other supernode, and you can do this in either order. You can either send both messages at the same time, or if you want to do some cyclic training, you can first have the first client finish and then the other client finish. Those clients are executing now. And let's say your colleague also wants to start a server app themselves. They don't have to deploy a new supernode. They don't have to deploy a new superlink, but they could just start a separate server app. And that separate server app would, of course, also send messages to those clients, and those clients would execute those messages, execute the local training, execute evaluation, or execute some federated analytics workload. Now let's say there's a third server app, and your third colleague also starts that, and that would just work seamlessly. So with that new model, we're in a situation where you can keep the server running, you can keep the clients running, and then you can start your individual training runs independent of that. What about central DP, local DP, secure aggregation, SecAct+, different implementations that you want to use to secure those workloads and to secure the data on those nodes? Well, today we're introducing built-in differential privacy. But not just that, we're also introducing built-in secure aggregation. And to show that, I want to give a demo. So first, I'm going to start something here, and then I'll walk through the code, and we can take a look at that once that has progressed a little bit. What we see here is a typical Flower project. We have the task, we have a simple PyTorch model here, we have some data loading code, we have some training code, we have some evaluation code, and we have the client and server part that we showed yesterday. So if you look at the server side, we have a plain strategy. It's just federated averaging here. And then we have the server app. Now in this case, what you can see here, this is running. This would be running without secure aggregation, without differential privacy. And the log output would look something like that. It gets initialized. We see the strategy sampled 20 clients out of 100. So this is simulates a federation with 100 clients. And then it just continues for 3 rounds, and it prints out the training accuracy. Now, what do we do if we want to enable this to run with secure aggregation, say? What we have here is the new Flower Next capability where we can register a custom main function, and we're piloting a new API that we call workflows. We're using the default workflow here, which closely resembles what we have in Start Server. But the big difference comes when we customize those workflows. So those workflows are composable, and we can just plug in a SecAct+ workflow. So this implements the secure aggregation protocol, and you can just plug it in on the server side like that. On the client side, we need to match that because the client side also is involved in this protocol, obviously. So on the client side, this happens via a mod. We introduced mods yesterday. Mods are just composable components that you can just drop in on the client side. And in this case, we matched the SecAct+ workflow on the server side with the SecAct+ mod on the client side. Now, if you run this, we get a slightly different log. We can see that in round one, secure aggregation is commencing, and then towards the end of round one, secure aggregation is completed. And it's really, once you get familiar with secure aggregation, SecAct+, and how these protocols work, it's really I'm pretty excited about this because it's a big step, and it makes using these very, very complex protocols very easy. And if the built-in protocols don't satisfy the requirements that you have, it's quite easy to also bring your own implementation. If you don't like the implementation that someone else has done, you could easily use the same abstractions and build your own secure aggregation implementation. And we'll use that to launch a lot more secure aggregation implementations over time. Last, but definitely not least, we also want to enable differential privacy. So for differential privacy, we've seen the original federated averaging strategy. Now we're wrapping that strategy in a rather long wrapper class called differential privacy, client-side fixed clipping. This means we apply the differential privacy, the noise on the server side, but we do the actual gradient clipping on the client side, just to show you the full breadth of what this can look like. So we're pairing this wrapper strategy with yet another mod on the client side, a fixed clipping mod. And with that tiny change, we've also enabled differential privacy on the server side with client-side clipping. And the final log would look something like that. We see secure aggregation is running. We see out of those 20 clients, all of them apply the fixed clipping mod, and they clip the parameter by a certain value. And then at the end, the strategy receives 20 results and secure aggregation completes. So that's a full workload with secure aggregation and differential privacy enabled. Now to show you that this is real, this is the workload we started earlier, and it's completed and it ran. Best news is all of this is available today in Flower Nightly. You can check out Flower Nightly and try all of that and look at the code examples, try out the code examples and customize them to your own requirements. I want to wrap up with a roadmap. So on the roadmap, we have authentication and authorization. We have this running in pilots already. And the full release is coming in Flower 1.9. In addition to auth support, we'll also launch user interface to manage runs, to manage client nodes and the like. We'll also improve Docker support. We'll provide the full suite of Docker plus Kubernetes with the necessary recipes to deploy this in typical production settings. And then we're also working on a high availability superlink so that you can deploy as many superlink instances as you want to handle just massive scale. That's it for the roadmap. But there's one more thing today. Today, we would like to welcome NVIDIA to the Flower ecosystem. Holger, come back to the stage.
Thanks very much, Daniel. Okay. Hi, thanks very much. I'm Holger from NVIDIA. Thanks for hosting this awesome event, bringing the community together. And we're really excited about this collaboration. So I prepared a couple of slides. By bringing Flower and NVIDIA Flare together, we hope that we can supercharge the entire FL ecosystem. So for people who are not familiar with NVIDIA Flare, it's our open source federated learning solution, which is industry agnostic, mostly focused on the production cross-enterprise use cases for different industry applications from healthcare to finance and so on. Of course, for running federated learning and production use cases, we have several multi-layers of security features going from the user identity and authentication to privacy-preserving algorithms. And we have several companies and institutions that use NVIDIA Flare in production. So for bringing Flower and NVIDIA Flare together, we're thinking of this first integration piece now, which basically enables you to take Flower server and client code directly and run that within an existing NVIDIA Flare runtime environment. So there are benefits for both sides. For NV Flare users, now imagine there is an existing federated learning system based on NV Flare. They can directly use the amazing algorithms and baselines that the Flower community developed and run that within the NV Flare runtime. And they can choose between Flower APIs or NV Flare APIs rather than having to re-implement things from scratch. For Flower users, they can now utilize a robust communication framework and features such as large object streamings that became available in the latest release. So we can enable streaming of message sizes of hundreds of gigabytes, which will become very relevant for the large language modeling. We can run concurrent jobs. It's basically like a cluster environment. You submit your job, and depending on the compute resources, they can be executed in parallel. We have integration with confidential compute on the GPU now with H100. And we have a pretty flexible communication framework. You can do server-centric communication or direct peer-to-peer. So with that, I wanted to show a demo on how easy it is to integrate. We can basically, in the easiest use case, we can use the client and the server code from Flower directly, and then wrap that with some configuration changes into an NV Flare job that then executes the client and server within the NVFlair runtime environment. And I'll switch to my, I guess I don't need a switch.
Yep.
Yeah, I'll run a little live demo. Okay. So rather than showing that you can run the Flower code without any code changes, I also wanted to show that we also can combine features from both frameworks. So there's one example here on the left. I have this job folder, which you submit to the NVFlair environment. It contains some apps for each of the clients and the server with some custom code, which in this case is the client.py from Flower. And then I also show some metric tracking feature that you can use from NVFlair. So here we use the Flower code, but with a few imports we can also use features from NVFlair. So we use a summary writer that's for TensorBot, metric streaming. There's also MLflow weights and biases available. And then in the Flower client train loop, we can basically, as the local training is going on, we can stream metrics like the training loss to the server. And then there are other things that might be useful, like we can initialize the Flare runtime environment here and then get some information about the system, like what is the client name and things like that, which are given by the environment. So if I run this now in the NVFlair simulator, so we provide a job folder, contains all the app information and configurations, some output path, number of clients, and you can specify the number of threads, like how many clients you want to run in parallel. And then now, of course, you get a mix of NVFlair outputs and Flower outputs here. And should take some. This is the Cipher 10 PyTorch quick start from Flower. So it's doing a small CNN training. And you should see the clients, like here you can see the environment starting up with the different sites. There's 3 clients in this case. And then we should see the output from Flower that I put in that script as well. There we go. And now the training is happening. So I set it up to be 4 local epochs before the model is actually sent back to the server. And we should see on the TensorBot already that okay, let me refresh this. Yeah, so the metrics are already being streamed to the server while the local training is going on. So that's the first time Flower and NVFlair, I guess, is working together. So thank you.
Fantastic. Thank you so much for that demo, Holger. We're really excited about the collaboration, and we can't wait to also make that all work with the Flower Next APIs we introduced, so that all of these workloads can also run on NVFlair. So that concludes the Flower industry update. We launched multi-run today. You can have 1 deployment and basically infinite runs. We launched discuss.flower.ai. Don't forget to join and join the conversation there. We have full support for running federated learning with differential privacy, with secure aggregation in a fairly easy way. And last but definitely not least, we are again welcoming NVIDIA to the Flower ecosystem and are excited about this new collaboration. I think we might have time for 1 question or so.
Yes, so we have time for questions. Any questions from the audience or online? Anyone online can ask questions via the Slack channel. So we have about 5 minutes allocated to this period. Here's a question down at the back, and I'm going to take it.
Hi, thank you very much for another round of good additions to the Flower ecosystem. Seeing the addition of differential privacy and secure aggregation, there's been a lot of discussion that federated learning or decentralized learning by itself cannot be enough to sustain thorough examination of some regulations. In your point of view, what's the Flower position after these additions, and what might be coming next? Thank you.
Yeah, excellent question. One thing I must add before I go into the answer, because it's related, the example I've shown only ran for 3 rounds, and you should run this for much, much longer, for many more rounds to ensure the privacy guarantees that you want to have, because you want all of the clients to be selected. And we only selected 20 clients and ran it for 3 rounds, so that's not enough to select all of the 100 clients. Keep that in mind when running the code example that we have. Regarding your question, it's a question that comes up every now and then, and I think it's important to look at each use case individually, because what we are seeing is that all of those many different use cases have many different requirements. So in some cases, it's sufficient to use just federated learning with secure aggregation, maybe. In other cases, you're not interested in secure aggregation, and all you should use is federated learning with some level of differential privacy. In other cases, you want all 3 of them. And in some cases, maybe federated learning purely by itself is sufficient. So I think the most important message to get across is it highly depends on the use case, and if you're not sure about a particular use case, for example, what this would mean for deployment, feel free to ping us.
Are there any other questions? Maybe Pan? No? Okay. Great. Well, thank you, Daniel. So our next speaker comes from the Open Data Institute. It's great to welcome Callum Ervete. And he is a senior researcher. And the mission of the Open Data Institute is to, I think, educate and increase the adoption of various kinds of technology. We've been having many conversations with them as to how Flower can help many institutions safely, intelligently apply different methods to do with privacy-preserving, machine learning, and the like. And I think they're doing a wonderful job in helping educate folks on how to use this technology and the importance of it. So over to Callum. He's going to tell us about pets and what he sees happening in the landscape of adoption in that direction.
Brilliant. Okay. See if this will work. So is there a clicker or? I can just run it through on the screen. That's fine. Okay, cool. Let's see, is this going to work? No. Oh, it's fine. I'll just. There we go, I can fast forward on this. Okay, little tech thing there, but yeah, so as Nick mentioned, I'm Callum Verarity. It's great to be here at the second day of Flower AI Summit. I'll kind of do a little bit of a quick overview of the ODI for those who aren't familiar with us. We're actually based just around the corner, so it's very convenient for me. And then I'll also go over a little bit on pets at the ODI, what we're actually focusing on. We come from a bit of a different position, as Nick was mentioning. We're a lot more kind of focused on the communication and the guidance and helping organizations to consider the adoption of privacy-enhancing technologies, including federated learning. So I'll go into that just very quickly, and then I'll belie my Scottish roots and be probably uncharacteristically optimistic, or at least I'll try to be, in giving a bit of an overview of the current pets landscape. So thinking about beyond privacy, we've already touched on, or some of the speakers already have touched on this a bit. Take that a little bit further. Also, pets and data institutions. This is probably a term that not many will be familiar with, but it's something which we've observed and identified as an interesting trend at the Open Data Institute. And then finally, focusing a little bit on pets beyond research. As has been touched on already, not just the purpose or the ways in which federated learning and analytics are being used just for research purposes, but then even specific sectors like health and finance. Those are the ones that we're always hearing about. There's an increasing load of examples which exist around that. So where are we seeing these technologies also being considered and adopted more broadly. So then, yeah, as with the previous session, then there will be a bit of time for questions at the end if I manage to keep time, and I'll try my best. So here we go. Right, so just very quickly, for those that don't know us, or me, the ODI. We were founded in 2012. You'll probably recognize at least one of the people up on the screen. We were really founded with the basis of trying to push for more open government data. That's how it started back about coming up for 12 years ago now. And then very quickly we gained a better appreciation for the importance of shared data and where data needs to also remain closed. I'll get onto that a little bit more in a couple slides' time. But then, yeah, ultimately, we're a non-profit organization with this vision of a world where data works for everyone and where there's possibilities for technologies such as federated learning to be used to be able to achieve that, then that's something that we're really interested in and hence an area of focus for us. So yeah, that leads me in nicely to Pets at the Open Data Institute. As Nick mentioned, we've been in discussions for a couple of years now. I've been with the ODI for about 2.5 years. We focused, well, shortly after joining the Institute, then I was tasked with working with the Rockefeller Foundation on a report looking into into federated learning and how this can be applied in contexts outside of the typical next word recommenders on phones, so more of the cross-silo applications of federated learning. So this little diagram that we've got here is something that we mocked up as part of that report, with thanks to Nick as well for those contributions that he made during that time. But then following on from that report, we've established a whole program of work which focuses not just on federated learning, but also on pets more broadly, how they can be used particularly for public benefit and in cases where there are benefits to broader society as well. So yeah, there's plenty of definitions that are floating around on what pets are. This is the one that we've focused on, and we like to give consideration to the fact that they're both tools and practices. So yeah, we can go way back, or we can also think about the more novel ones such as federated learning, and these are the kind of purposes that we think that they're primarily used for. So I mentioned about the whole open, shared, closed conundrum. Well, at least it's a bit of a conundrum for me, seeing as some of these privacy-enhancing technologies, they might blow. This is what we call the data spectrum at the Open Data Institute, and this is a kind of tool that we used, or we developed quite a few years ago, way before my time, but it's still pretty prescient in helping organizations, because we work with governments, we also work with companies to help them consider where they can make data more openly available. But then this is an appreciation of where some data needs to actually remain it's gone. Either shared on a more limited basis or closed. So this is kind of like a keystone thing or tool that we use with different organizations. And it's not necessarily to the extent of keeping me up at night, but when I've started working on privacy-enhancing technologies, and then when I've been focusing on how these can help enable data access rather than data sharing, then yeah, I've been in some conversations with my colleagues as to whether I can come up with a new slide or a new spectrum which has pets straight across it. So yeah, to really kind of increase or open up more access to this data whilst actually retaining the privacy of the data or the subjects that the data is actually about. So yeah, it's an interesting one. And at times I've wondered, are pets antithetical to open data? Or can they actually peacefully coincide, or in collaboration with each other? And I'm leaning more towards the latter. I still see that there's value for open data. It's maybe not as much of a hot topic as it used to be, but that's where pets is coming in. Yeah. Oh, I'm seeing that I've only got 4 minutes to go. I need to get going. Right, sorry, I'm going to jump ahead. So pets landscape, the more interesting stuff. So I said that was going to be a bit more optimistic or yeah, positive about things. And this is essentially based on some of the interactions that I've had at the Open Data Institute. As I said, we work with different companies and different governments and help them try and realize the value of data through various different means, including through pets. So yeah, just moving forward. Nick and I, we had a bit of a conversation about what I might look to cover or include in this presentation. He gave me relative creative license with it. So one thing that we wanted to focus on, though, or I thought would be worthwhile paying some attention to, is just this narrative around beyond privacy. This is something which isn't necessarily a new trend, but it's something that's certainly developing or gaining a lot more currency. The diagram, which you might not be able to make out, but I'm happy to share this stuff around later, is a diagram that we came up with as part of our research when we were doing our work on federated learning, thinking about the other benefits that can actually be achieved through using certain privacy-enhancing technologies, in this case, federated learning, where the size of the different sort of spheres, or circles, I guess, in this basis, are relative to the value that can actually be gained through using different technologies. And then in this, you can see that confidentiality is a little bit lower, whereas scalability, particularly for federated learning, is an actual much bigger selling point. And so what we're seeing is that as familiarity with different privacy-enhancing technologies is increasing, then we're seeing people looking beyond just the headline privacy-enhancing technologies and thinking about the other benefits that these are actually enabling. I'm going to scoot forward very quickly. Pets and data institutions. Data institutions, this is a term that we kind of coined at the Open Data Institute quite a few years ago. We consider data institutions organizations that steward data on behalf of others for public or charitable aims. So this is, a lot of research has gone into this, and this is kind of like a fundamental piece of work that we actually help deliver or with different organizations. And you can see here, maybe you can make it out, that we talk primarily in terms of 4 different components which are necessary for good data institutions, and we think in terms of the legal foundation, technical infrastructure, you can probably see where this is going, and then the governance processes and the commercial terms. So yeah, something that particularly in the past couple of years, as maturity of certain privacy-enhancing technologies and familiarity with them has increased, then we're seeing this being incorporated into our thinking of how data institutions can help facilitate safe access to sensitive data. You can see at the bottom there's a bit of a link to that, so I can send that over as well at some point. But I'm actually just back from, I was over at UK Southeast Asia Tech Week in Bangkok, even though, yeah, you'd probably not be able to guess it, just a couple of weeks ago. And there was such enthusiasm for these different privacy-enhanced technologies. Particularly, we got talking to the Digital Government Development Agency, who are very interested in looking into how they can look to prevent online fraud and scams, particularly through the creation of a data institution which would will incorporate elements of federated analytics to be able to help access the data that they need in order to be able to build cases and prosecute offenders. And then similarly, actually, I just got back last night from the Data Spaces Symposium. I've got 1 minute. Okay. Just very quickly on that, it was really interesting to see. I'm not sure if people are familiar with data spaces. Come and speak to me afterwards. I won't spend too much time talking about them just now. Yeah, it was really interesting to see that these EU initiatives where they're looking to bring industry and tech providers together to increase access to data for innovative purposes, then they're increasingly also considering the use of privacy-enhancing technologies, and namely federated learning. I've got some examples which I can talk about when I've got more time. Anyway, so I've got probably about 30 seconds to cover this. So beyond research, interesting areas beyond finance and health, advertising sector. Bit of an iffy one, but yeah, it's really interesting to see, particularly with the ongoing consideration or the move to removing third-party cookies or degrading them. Then we're seeing a lot of activity occurring in the online ad space, particularly trialing out of various different privacy-enhancing technologies. And yeah, I think it's already been mentioned, but we're not yet at a position where there's kind of prescriptive cases. There's a clearer picture becoming available on that, but then the deployment of pets just entirely remains context specific, whether that's a small tailoring that you're doing to it or the entire access model that you're actually looking to use. I'm going to skip my next slide, probably because I'm out of time, and I'll just say thank you for just now.
Thank you, Callum, for that wonderful talk. I mean, I think the 2 main themes you just introduced was that you see pets being adopted quite widely in various types of industries, and then also that how pets is evolving beyond just being about privacy, but pets like federated learning offers many advantages: compliance, performance, confidentiality, so many. So with that, let's take a few questions from the floor. We have time for 4 or 5 minutes of questions. Any out there?
Cool. Thanks, guys.
Hi. We've got The issue of compliance and regulations come up a few times now. So a key thing there, from my perspective, is the role of validation rules. Where does that fit into any of the sort of frameworks we're talking about?
I might actually need to rely on you for answers to framework questions.
I would say, what do you mean by validation rules?
Okay, well, if by definition, if you've got regulations and compliance stuff concerns, you have to have some way of saying, is this certain thing true or not? How do you check for the compliance and for the regulation stuff?
Yeah, I think
you should answer the question.
I'll try my best at least. So no, thanks for the question. Yeah, it's something which there's still sort of evolving guidance on. Obviously, the ICO came out with their recommendations or their guidance just last year, which was a bit of an update. I think that ultimately, yeah, we're still kind of like asking ourselves about this in certain instances, particularly with the deployment of federated learning at the ODI, where we're still obviously bearing in mind that while it can help with compliance, it doesn't necessarily answer all questions. So, I mean, you still do need to think first and foremost about various different aspects of the GDPR. Particularly, we did a bit of research as well where we found that it can perhaps even encourage some actors to think about less focusing on data minimization where possible to actually collect more. Because there is perhaps maybe misunderstanding around exactly who is responsible and whether you're considered as a data controller just because you're not necessarily actually handling the data. But then if you're instructing that or informing that decision, then technically you are still a data controller. So yeah, I think that there needs to be more communication around that as well, just to make sure that everybody's clear that, yeah, you don't necessarily immediately circumvent any requirements under GDPR. So yeah, that's about what I'd say.
That's fair. More questions, maybe online. Pan, any question? No? From the room?
Hi, thanks for the talk. I was wondering if you had any advice or resources for like researchers who have developed methods who like are trying to communicate pets to like people that have access to the data. Yeah,
kind of actually. I didn't manage to incorporate, but I think like Nick actually got in touch with me after he saw an explainer that we came out with actually on secure multi-party computation, how it's applied practically. So yeah, this is actually the kind of area that we're working in at the moment, doing a lot of the communication and translating. Yeah, I was actually thinking, I didn't manage to make it yesterday, I just got back last night, but I sort of feel as though I should have probably sat in between the research and the industry day, because it's yeah, exactly what we're working on at the moment, so I'd be more than happy to send you some of the materials that we've got and have a chat with you about how you might look to do that yourself.
Any other questions from the floor? No? Well, thank you, Callum. Thanks so much.
Thank you.
So it's my honor to introduce our next speaker, is Dr. Nathan Gore. He is an assistant professor of data science in the Department of Operational Sciences at the Air Force Institute of Technology. He is going to be speaking to us about one of the sort of overlooked, I think, application domains of these technologies. And so there's a variety of problems in data management and modeling and machine learning that exist within the military. And he's going to be explaining how federated learning can play a role in addressing some of these needs. Just a bit more about him. He received all of his degrees from bachelor's to PhD from Arizona State. He did a postdoc in the Mayo Clinic. And he is also, he serves as the chair of the Informs Data Mining Society. And I remember we met for the first time in Flower Summit last year.
Yes.
Yeah, so thanks for coming back. It's wonderful to hear the story. Yeah, thank you. Thank you so much for today.
Awesome. Well, welcome and thank you for joining today's presentation on the intersection of military applications and advanced learning technologies. My name is Dr. Nathan Gaw from the Department of Operational Sciences at the Air Force Institute of Technology. This is one of the 2 graduate military institutions in the United States. And today I will be presenting how federated learning is paving the way for innovative solutions in military strategy, cybersecurity, and medical applications within the military as well. So in today's presentation, I'll start by discussing the background and motivation behind our research. We'll explore case studies in military applications, including network intrusion detection and Parkinson's disease prediction. And our goal is to highlight the significance of federated learning in addressing these critical areas. So the modern military landscape is increasingly complex, requiring novel solutions that respect security and policy constraints. Federated learning offers a promising avenue, enabling collaborative machine learning without direct data sharing, and thus overcomes traditional barriers to data utilization and in sensitive environments. So here are a few examples where federated learning can be applicable in the military domain. And so I'll highlight a few of these. First is in cybersecurity. So within cybersecurity, federated learning can enhance these efforts by enabling collective learning of attack patterns and vulnerabilities across military networks and systems. My lab is currently doing collaboration with the Army Cyber Institute at West Point. And we've actually come up with a few interesting results, especially in the active learning and semi-supervised learning domains. Additionally, within the area of predictive maintenance for equipment, military equipment, including vehicles, aircraft, and weaponry, requires regular maintenance to ensure operational readiness. Federated learning can be used to develop predictive maintenance models by analyzing sensor data from equipment deployed in different locations. These models can predict failures or maintenance needs, optimizing maintenance schedules and reducing downtimes. And finally, maybe a little bit less expected for discussing within the military application, but health monitoring for personnel is also incredibly important. This is something that I personally have a background in for about 7 years, and so bringing this into the military context is still very important for me. And so within federated learning, this can be used to have individuals have wearable sensors or have some type of remote collecting devices such as smartphones to collect physiological data from military personnel in different locations. And by leveraging federated learning, healthcare providers can develop personalized health models while ensuring data privacy and security. So the first case study I present is on active federated learning for network intrusion detection. This research was conducted by one of my recently graduated master's students, First Lieutenant Matthew Sauer. He's currently stationed at Barksdale Air Force Base in Louisiana. So cybersecurity threats are growing increasingly complex, particularly for the US military. Traditional detection methods are struggling to keep pace with the constantly evolving threats. The expanding Internet of Things landscape, comprising of billions of vulnerable devices, demands protective measures. Federated learning has demonstrated effectiveness in these IoT environments prone to cyber attacks. However, labeling all IoT data for model training is impractical due to its sheer volume. And so active learning emerges as a machine learning approach to address this challenge by reducing the need for extensive data labeling, and especially within the context of federated learning, and when it gets to such a large scale, this is incredibly important. In real case scenarios, we can't simply label all of the data. We have to come up with solutions to identify which parts of the labeled data are the most important. And so basic idea of active learning is it identifies which unlabeled instances within our data set are the most informative to label. So a model will predict on the unlabeled data set based on sampling strategy, and uncertain samples are labeled by a human / oracle. And so this figure below represents the general idea behind active learning. So if we chose to just simply randomly label instances, we would get our middle figure here, which would maybe give us some useful advantage. But really what would give us the main advantage is what are the data instances right at that margin where we're the most uncertain about. And this is what will power our model to perform the most effectively. So our experimental setup includes a data set split among 4 different clients using federated average strategy, focusing on a binary classification task where we have a number of clients that have benign or malicious data packets coming into this cyber system, where we have a handful of different maligned data packages for each of these different clients, just to really show the ability of this framework to handle different instances. And so general strategies that we looked at for this is 1, no additional labels, only 1 attack and 1 benign label for the particular client. 2, randomly labeling samples, so just like that middle figure a couple slides ago. 3, querying the first 10 samples for which the model is uncertain. So we had a particular threshold that we used to identify uncertainty for labeling that particular sample. And then 4, querying the 10 most uncertain samples for that particular communication round. And so these 4 results indicate the performance of our model. And so as you could see, the one on the upper left-hand side just represents having 1 benign and 1 malicious sample and just letting the clients run. The second one is random query, and you could see there's quite a bit of variability and uncertainty in regards to that. The next one is labeling the first 10 uncertain samples as they come into the system. And then finally, we also have the 10 most uncertain samples, which produces, of a single communication round, which produces the most stable results. And so, as you can see, federated active learning has shown that it can achieve similar results with a lot less labeled data. Previous work used around 500,000 samples, while we labeled at most 2,000 samples to perform, which is only 0.4% of the data. And so this work shows the need to develop methods to overcome the large amounts of unlabeled data in the Internet of Battlefield Things. And these preliminary results are just one of the many things that we've been working on. But just something initial to show to you guys, showing the promising value of federated active learning. And so transitioning from cybersecurity, let's delve into medical applications of federated learning. The same principles that protect our networks can also safeguard our most precious asset, the health and well-being of our military personnel, which is something that I want to bring from my own background into the military context. And so we'll explore how federated learning is making strides in diagnosis and treatment of health conditions. I have done some work in post-traumatic headache, but we're going to do main focus into Parkinson's disease. Interestingly enough, there are a number of veterans that struggle with Parkinson's disease, actually higher than, it's shown that statistically higher amount of veterans deal with Parkinson's disease because during the Vietnam War, chemical agent, Agent Orange, was used against, and other herbicides was used against our military personnel, which has a much stronger chance of affecting somebody with Parkinson's disease. So traditional ML methods are unable to pull large amounts of data from health data due to privacy-preserving laws. So in the United States, that's HIPAA. However, with federated learning, that makes it possible for learning in a distributed fashion. So the next case study I will present is on adaptive client selection for Parkinson's disease prediction. The research was conducted by one of my PhD students, Jen Alsop, who is currently at Wright-Patterson Air Force Base. So Parkinson's disease is the fastest growing neurological disorder. Patients suffer from this disease and are highly heterogeneous in nature. So they can have problems with movement, tremors, voice impairment, memory issues, and effective treatment may slow down the progression. The typical measurement that's used to determine the severity of somebody's Parkinson's disease is the Movement Disorder Society Unified Parkinson's Disease Rating Scale, referred to as MDS-UPDRS. And one solution that we have been working on for the past few years is in the domain of telemonitoring, which is the use of electronic devices such as smartphones to remotely monitor patients. And so we will talk about a data set called the Empower data set a few slides from now, where we're able to collect different information about individuals with Parkinson's disease on a daily basis to quantify their disorder. So very typical in this application, so in the domain of Parkinson's disease, when somebody has Parkinson's disease, you don't know exactly what that means and what disease conditions they're experiencing. So everybody with Parkinson's disease has different expressions of that particular disease throughout that progression. And so knowing how to handle heterogeneous individuals or heterogeneous clients within a federated learning framework is very important. And so when clients are heterogeneous, the machine learning algorithm can experience significant problems during training, and non-independent and identically distributed data can lead to the global model not generalizing well and experiencing biases towards some of the clients, leading to slower convergence and suboptimal performance. So some ways to mitigate challenges from heterogeneous data is by performing client selection. Client selection algorithms estimate the value of federated learning clients and then adaptively sample valuable clients. There are many ways to determine clients' value, but the most common ways are to select clients that have the highest cumulative loss or high divergence from the global model, so we can improve general performance of the global model. And another method is to avoid noisy or malicious clients. And so there has to be a threshold to identify, at what point is somebody noisy client or malicious client, and we might not want to incorporate that client into our model training. And so there really is no one-size-fits-all solution, and it's typically very problem-dependent. And so, for this particular application, we really wanted to identify, what were those individuals that were, that present a good diversity of clients, but not too much. So we looked at 3 different adaptive client selection strategies. The first one was a greedy algorithm, looking at which clients in a particular round would improve the accuracy as much as possible. We also looked at another method called upper confidence bound, and this looks at a number of possible actions and distributions based on average past performance and number of times that action has been selected. We might not want to select the same client too many times in a particular communication round. And then also Thompson sampling, which is a Bayesian approach to selecting actions using beta distribution function for our prior and updating our beliefs after every communication round. So for our particular data set that we had 37 Parkinson's disease patients, for which we looked at those as our 37 different clients. We had the Empower smartphone app, which collected data daily from these Parkinson's disease individuals for a period of about 6 months. And there were 2 different features that were collected. One was voice features, and the second was tapping features. So as you can see, exercise was pretty simple for the voice features. It was asking the Parkinson's disease patient to say "ah" into the microphone for as long as they can. And through a variety of processing algorithms, we were able to obtain a handful of voice features. And then similarly with the tapping features, seeing how precise an individual's motor capabilities are. And users were instructed to tap between 2 dots as quickly as possible. And the main goal of this task is to predict the severity class with smartphone collected voice and tapping data. So here is a general setup for how we split up the clients. So to keep the model relatively fair, we did try to have a relative diversity of instances within initialization of the server, as well as a validation set and test set. And then the non-circled clients here are those individuals for which we will select during the model training process to try to perform as well as possible on that held out test set. And for our data pre-processing, we only consider the last entry of each day for the patients. So patients were instructed to collect data 3 times a day. We decided to do their last entry because it's probably the time where they're the most normalized. They've taken their meds and everything else. And we also standardized the features. Initialization, so we did 5 training rounds of initialization on those first 3 clients, and then we looked at these different client selection strategies. Here is the general outline of our test setup. So we had 5, 10, and 15 clients adaptively selected for each communication round. We wanted to see what number of clients do we have some benefit for adaptive client selection. We had 20 different communication rounds, and our model was a multi-layer perceptron, MLP, with 3 layers. with a ReLU activation function using an atom optimizer. And so for 5 clients, you can actually see that there really isn't any method that's significantly better than the federated average method here. And so we see that adaptively selecting 5 clients doesn't seem to be very beneficial. When you get to 10 clients, we actually see right here that UCB1 performs significantly better than all the other methods. And Thompson sampling performs pretty well as well. And we can also see at 15 clients relatively similar performance. So we can kind of see that our saturation is met around the 10 client round. And so in summary, the number of sample clients impacts statistical significance from baseline methods. When there are enough clients proposed, adaptive client selection methods performed significantly better than federated average. We found a UCB1 performed significantly better in most cases. There are a few cases where Thompson sampling performed better. And adaptive client selection methods can decrease training difficulties due to non-IID clients. And so in conclusion, these 2 case studies demonstrate that federated learning can alleviate barriers to accessing the full potential of machine learning and AI to make strategic decisions and access real-time relevant data. Federated learning is especially desirable for military application, where the battlefield is dynamic, dispersed, and resource constrained. And so with the expansion of IoT devices, researching and expanding the security and efficiency of federated learning from a military standpoint will become more prevalent. And so with that, I'd like to open up the floor for any questions that you might have for me.
Yeah. Thank you so much for the talk. It was very good. We've got a question already, and then Daniel. Okay, we'll take that one first.
Thank you for your presentation. So my question is related to, are you planning to work also on decentralized fashion, maybe for the interested area that cannot reach internet, that cannot reach a central aggregator server?
Can you rephrase that question? I didn't quite hear what you...
So my question is, are you planning to work also on decentralized learning, maybe for interested area in which that cannot reach a central server, that cannot reach cloud, the internet, and so on?
Absolutely. And so, yeah, especially within the cybersecurity perspective, we're looking into applications too where, yeah, instead of focusing on the basic aspect of federated learning, updating a global model, there might be instances where it may make sense to have clients adaptively serve as the training in the global model in different perspectives. One particular aspect is in the context of space. So I'm actually working with some folks from University of Central Florida, where we're looking at applications where, learning is very decentralized, and even the global model, it almost makes sense to trade spots with different clients just because of, the aspect of space. So there's, much less communication up there. And so, we're looking into some applications in regards to that.
Thank you very much.
Ruth, let's take the gentleman at the back.
Thanks very much for the interesting talk. So, can you elaborate on the role of privacy when you apply federated learning in cybersecurity context? If all the devices belong to one military base, why won't you just concatenate them, just run regular machine learning on the central?
Yeah, that's a good question, and I think it requires some thought for the particular cybersecurity network that you're looking at, and so. There might be some cases where that would make sense, within your particular IoT system to have things separated from each other, even within a single military base, because you would want to avoid leakage of malicious data packets from one area in an IoT system to another. And so keeping it private can be helpful.
Yes, but that is privacy. You need authenticity. But in order to authenticate data is different from to preserve the privacy of the data. By preserving the privacy, you won't solve the authenticity of the data, right?
Yeah, that's actually a really good point as well. And so, you know, within a military base, if there is some method to authenticate the data packets, you know, that might not necessarily be quite as important. And so, you know, we look at this context with, you know, even collaborating with a variety of other, you know, allied countries. And so, you know, sometimes, you know, although we are friendly with, you know, various other allied countries, you know, it might still be good, you know, in everybody's interest to keep our data private with each other and not share. And so, you know, probably, you know, you do make a good point about the authentication. If there's a way to authenticate the data, you know, it might not be, you know, necessarily as important. You know, that data can be locked, you know, within particular IoT systems. But, you know, definitely for, you know, collaborating with other military and, you know, allied military, it can, yeah, privacy can still be of some importance. But you do make a great point in regards to the authentication.
We're going to take a question from online.
Well, a quick question about the mPower dataset, the Parkinson's disease. Will this dataset publicly available now? So if not, do you have a plan to make it public?
Yes, the mPower dataset is publicly available. You have to go through an approval process to get access to the data. Yeah, for the person online who asks, you can contact me at nathan.gaw@affit.edu. I can tell you how to get access to that data. Yeah, again, you have to go through approval process, but it doesn't take too long to get access to the data.
Cool, thanks so much.
Let's thank Nathan for the great talk. Thank you so much. So we're going to transition now to the poster session. Throughout the building, there is around 17 different posters, but to allow you to sort of see what these different posters are about, some poster presenters have decided to provide a one-slider, so they're each going to have an opportunity to give a one-minute presentation and advertise what their work is about. I'm going to read out some names. If you hear your name, please come to the side, and we're going to go through your slide one by one. So the names are Severin, there is Raj, Daniel, Amandio, Alicio, Yusov, Wanru, and Connor. And that's the order that we'll go in. Yeah, so essentially in the audience here, you're going to hear a one-minute pitch about that poster, and that'll give you a good idea about what that poster is about. You can go see it. For those online, don't stress. During the break, when the poster session happens, you're going to see a short clip from the various posters, so you can also enjoy the material as well. So with this, let's start our 1 minute. Over to Severin. So Severin Pang is a data scientist at the EI3 company.
Hi everyone, great summit so far. My name is Severin Pang. I work for EI3. At this company we have a huge focus on predictive maintenance. So predictive maintenance model can roughly be categorized into two different approaches. One is you model based on the physical understanding of the machine. The other is more data-driven, where you use large-scale machine learning in order to predict what's happening. And both have their unique advantages. And we therefore came up with a mathematical approach where we combine these two methodologies. This mathematical approach is applicable to PID controllers. PID controllers are almost in all industrial machines an integral part. And what we do with this mathematical application is we compute the configuration of the PID controller. Now, these configurations don't entail any information on how they are operating the machine. And therefore, we can compute these at each individual machine. And using federated learning, we can then centrally store all these configurations and compare hundreds of machines against each other to detect anomalies. And that way, we've been able to detect component failures as well as processing issues on different machines. So my poster's right at the entrance, and I'm excited to see you there.
Thank you. So the next is Raj Mani Shukala. He is an assistant professor at Angela Ruskin University.
So hello everyone. So my poster is on like using vertical federated learning for CVD risk prediction. If you have heard about the maybe vertical federated learning, so here what we do is that, so instead of the different clients having same features, the different client might have different types of the features. For example, one client might be hospital, where the doctor might be recommending you something. Second client may be lab, where your test has been taken, and third client Yeah, and third client can be your smartwatch. So these different clients have different type of the data or different type of the features. So we propose some algorithms to combine these data together, and we tested it against normal centralized like machine learning, and we found that the performance was equivalent. And in future, what we are trying to integrate further is that suppose there are some malicious clients, then how we can handle it. So we did some of the work on this, and we found that using some statistical method, like using median and mean absolute deviations of the weights, we can find the malicious clients. Second area that we are working on is the data leakage. So there can be data leakage. We have a differential privacy, but we are further trying to improve that because differential privacy might not be 100% correct at every time. Third area is on trust, that how we can integrate explainability or trust in the federated learning systems. Yeah, thank you.
So next we have Daniel M. Jimenez. He's a data science PhD student at Spianza University of Rome.
Yeah, hello everybody. I would like to invite you to see my poster that is about Fed Art ML, and you can see the art word there. That is for the art that we are all doing together here with Federated Learning. And also I would like to explain a bit of where it comes from. So I am sure you know this guy over there. You have seen him someday. And if you think what was his best creation ever, you can say that it was any of the iron armor, the reactor. But if you think through, you will see that the best invention was the artificial intelligence tool that he had, that was Jarvis. And the reason is because with that one, he was able to create plenty of his best stuff. So I want to introduce you our best invention so far, that is called Third-Art ML. Basically, we can take a centralized data set, any kind of centralized data set, and we can convert it into federated data sets. And very importantly, we can control the level of non-IIDness, how the data is different among the clients. We can work with labels queue, features queue, quantities queue, and I will stop here because I want you to go and watch it, right? So thank you very much, and it is right there close to the toilet, so you will see it for sure, okay? Thank you, bye.
We now have Jan Bozic from the University of Ljubljana.
Yeah. Okay. We're here with Amandio to present Collext. We built a testbed for solving a problem that most of today's research algorithms are tested on simulated environments, and now we want to test it on physical, real devices. So we built a heterogeneous testbed of 28 SBCs and 20 smartphones running Android and Linux to test your code. And we want to expose it to developers and researchers so they can post their new improved algorithm and get back hardware metrics along with machine learning metrics and determine what are the pitfalls of their new algorithm or improvements in efficiency or in convergence. So this is the picture of our testbed, and if you want to get to know more about it, there's a poster right there, and come say hi during the break.
Next we have Alessio Catalaflamo. He's a postdoc at the University of Messina.
Thank you. Okay, I'm Alessio, a postdoc at the University of Messina. So our work was related to homomorphic encryption in federated learning. So homomorphic encryption is often associated to federated learning because, as we all know, scientific literature proves that from ways it's possible to recollect and to leak original data. So our work is a practical work because we exploit Flower and Tensor library, that is a famous library for homomorphic encryption provided by Microsoft. We implement a custom strategy exploiting the already present, the abstract strategy of Flower. We implement a custom strategy to use encrypted version of Fed average and Fed prox in a transparent way for the final developer because it uses a simple strategy like Fed AVG or Fed prox built in. So it it's an easy integration in Flower, and it can be made available for to the community. Thank you.
Our next speaker is from the University of Gachon. He's Yusuf Farakod. He's a researcher.
Hello everyone, I'm Farakod from Gachon University, and we are creating currently solving heterogeneous problem using Flutter, and we using CoreML and TensorFlow provided by Flower, and currently we're training iOS and Android devices with same server. And we have also server solutions to deploy your model and datasets. So our poster is downside, and you can come and see. Thank you.
The next we have Wanru Zhao. She's a PhD student at the University of Cambridge.
Hi everyone, I'm Wanru from Cambridge. Today I would like to present my paper about enhancing data quality in federated fine-tuning of foundation models. So I would like to first start from large language models. People all know that large language models benefit much from training the high quality, large amount data from the public side. But what if we are running out of the public data? So federated learning becomes a solution for that. To further scale the model up, it's very important to incorporate various domains to make the collaboration of the specialized and high-quality data sources from the private domains. But there are many challenges in terms of the data quality control when it comes to the federated fine-tuning of large language models. So today I would like to present and propose a new automated data quality control pipeline for federated fine-tuning of large language models. And it would incorporate data valuation and attribution method as scoring functions to evaluate individual training sample quality. And also it established a unified data quality standard using the anchor data to address the heterogeneity across different institutions. So in that way, we can eliminate the low-quality data, enhance the model performance, and preserve privacy. So I believe that collaborating with multiple private domain data sources will open many possibilities in the face of public data exhaustion. And I'm currently looking for a research summer internship. So welcome to my poster, and looking forward to discuss with you.
Thank you. So our final poster presentation is going to be presented without a slide. We have Connor Hassan. He's a visiting stats and ML researcher at Universidad del Silva Italia.
Yeah, I'm also a PhD student from Brisbane, Australia, and we've been working on methods for fitting hierarchical Bayesian statistical models in federated learning settings. And the main sort of application we're interested in is in cancer epidemiology. There's lots of cancer atlases that are being fit to data from across these large geographies, and the models underlying these atlases, you have these local parameters that explain disparities between certain population subgroups. So it's really important that you have this hierarchical model structure to explain disparities. Yeah, so my poster's over there in the corner, so check it out.
Great, thank you so much. So that concludes session 1. We're going to take a half-an-hour break. I'd invite the people online to enjoy the 5-minute videos of the posters. Those here, please visit the posters, but also partake in the refreshments. Yeah, thank you very much.
Hello everybody, this is Lorenzo Carnevale, Assistant Professor at the University of Messina. Along with my colleagues, we worked on a novel federated learning framework for mobile edge devices, such as robots. This is why the Robot Operating System, ROS, is at the center of the discussion. Let's step back for understanding the context. It was 2017 when McMahon and his colleagues from the Google Incorporation released a paper discussing on a communication-efficient learning methodology based on decentralized data. Local data were trained locally on decentralized clients, and the model's weights were shared with an aggregator server, which performs averaging by using the federated averaging algorithm. Such a paradigm was therefore named Federated Learning. Federated Learning has found applications in many domains and industrial sectors, such as smart city, healthcare, and robotics. In the latter domain, robotics, greater interest has aroused the convergence of federated learning and unmanned aerial vehicles used for the optimization of communication or resource allocations. Many federated learning frameworks have been already released, but no solution for ROS-based application have been implemented yet. Moreover, ROS2 communication is based on the Data Distribution Service, a standard for data-centric publish-subscribe. This means that no existing framework may fit as it is. As an alternative, Federos is built on top of ROS2 for enabling federated learning on ROS-based mobile edge devices. Federos is designed to be a platform-as-a-service cloud computing model for the submission of federated learning jobs. Federos user implements model, optimizer, and loss function by extending abstract classes. Such files, along with hyperparameters and dataset, are organized in a YAML manifest, which becomes the input of the application. We faced two main issues. The first one is related with the ROS2 needs, that are the building in runtime of client and server packages. However, we didn't know a priori the manifest that the users submit. The second one is related with the communication system, because ROS needs to define a message format before of the building phase. We created two not self-sufficient ROS2 packages. Model, optimizer, loss function, dataset, and hyperparameters configuration files land on the packages after a composition phase. The Federos client package has a training node, which implements the methods to train the local model, while the Federos server package has an aggregation node, which implements the FedWG strategy. Therefore, we compose also the interface message as the programmatical extraction of layers name, number of parameters, and shape. This is an example. Finally, a Docker Compose was programmatically made for running client containers and server containers on the machine for the simulation. The experiments aim to evaluate the time performance of the Federos client and Federos server packages. The generation of all the files is characterized by input-output operations on disk, but in particular the interface configuration takes more time, as the framework must analyze the structure of the neural network model to extract the layer's name, the number of parameters, and the shape. Finally, the Federos framework fills a gap in the utilization of federated learning in mobile edge devices, for example robots. The framework has good performance and represents a benchmark by itself. In the near future, we will act for testing the client-server communication efficiency, both for the publish-subscribe model, which is already implemented, and the client-service model, also native in ROS2. This is an asynchronous communication system and promises a faster interaction. Furthermore, we would like to simulate a real scenario distributed environment, for example, a swarm of drones. These are my contacts, feel free to keep in touch with me, and this is the bibliography used for this presentation. Have a nice day, bye!
Hi everyone, and welcome to my poster presentation on exploring the interplay between federated learning and energy systems. The poster covers our latest results at the Group for Distributed and Operating Systems at the Technical University of Berlin. in carbon-efficient federated learning, as well as how to test the interaction of such distributed computing systems with the energy systems. So to reduce the footprint, the carbon footprint of federated learning, it is key to understand where clients draw their energy from. And this might be obvious for smartphones or battery-powered IoT devices, but especially in cross-silo federated learning, we often encounter very big clients, very power-hungry clients that are connected to the public electricity grid. Or maybe even clients that have access to their own on-site renewable energy generation or batteries within a microgrid. Now, one example for reducing the operational carbon emissions of FL is optimizing for renewable excess energy. And this energy occurs whenever there is more supply than immediate demand in a local energy grid. So since not all of this energy can be transferred to other regions or stored in batteries, we often encounter curtailment, meaning we have to waste this energy because we cannot match supply and demand. And this happens more and more since we deploy more and more variable renewable energy sources, like solar and wind. And for example, here we can see that in 2022, California had to curtail almost 7% of their entire solar production. So this energy is going to waste. We propose a federated learning system architecture, as well as a client selection strategy, which optimizes for this renewable excess energy, as well as spare computational resources at clients. And we ask the question, how can we perform a reliable and efficient federated learning training in such a volatile and unreliable environment? For this, we had to address several challenges. For example, the issue of fairness in such a system. So how can we avoid bias towards clients that have lots of excess energy available? Or the other way around, how can we avoid that clients with very little access to excess energy are underrepresented in the final model? Federated addresses this by dynamically adjusting the pace of training and by prioritizing clients who were so far not able to participate sufficiently. However, this is only the beginning, so there's a lot more potential for greening federated learning if we have visibility and control over the client energy systems. However, real hardware testbeds are very rare and expensive to build and maintain, so we developed a co-simulation framework called VESIM, which is able to simulate exactly that. So it combines several already existing domain-specific simulators, for instance for solar generation, wind generation, energy storage, the grid itself, and so on, with the help of a co-simulation engine called Mosaic, which allows us to connect these simulators with real or simulated federated learning clients. And during training, the clients periodically inform the simulation about their power demand, and VESIM then simulates where this power would be coming from. And through the use of controllers, we can then simply monitor the system state and the behavior of our system, for example, by tracking carbon emissions, battery state of charge over time, etc. in a database. But we can also actively control the clients, for example, by switching some clients to power saving mode in case the simulated battery is running low. We can expose a REST interface that clients can query to get information about the state of the energy system and so on. And this bidirectional coupling is something that is has not been possible with current tools. So computing system and energy system can influence each other with VESIM during experiments. We also call the software in the loop simulation. And a main goal of VESIM will be exploring this interaction. So what are meaningful and also what are safe interfaces between federated learning systems and energy systems? VESIM as well as FedZero are openly available on GitHub, so please try them out and feel free to reach out to me in case of any questions. Thank you for listening.
Welcome to the future of sustainable mobility. Introducing Green, a platform based on federated learning, blockchain and smart contracts. Developed by HE Iberia, Green is designed to securely apply artificial intelligence to Internet of Things data. Green is focused on optimizing the charging station for electric vehicles. The focus lies on improving the charging infrastructure to encourage the adoption of electric vehicles and mitigate pollution. Now, let's see how it works. Here we have a charging station. This station supplies power to electric vehicles and, at the same time, records the electricity consumption throughout the day. Through this data, the station can train its own local model to predict its future consumption. However, in a city, we face a dilemma. Each station has its own local model, but local data is not sufficient for accurate models. So, how do we solve this? The answer is collaboration. But there's a problem. Each station belongs to a different manager, and they don't want to share data. This is where Green comes in with its innovative technology. Green uses federated learning and blockchain to overcome this obstacle. Each station has its own local models. Thanks to the blockchain, we create a network to evaluate and vote the local models, ensuring we get the best possible results. Now, thanks to the federated learning, instead of sharing data, stations combine their local models to form a global model beneficial for all, and this global model is updated in each round. Additionally, this model is securely stored within the blockchain along with the smart contracts and other data. But what happens if a station tries to act maliciously in the network? It's time to dive into the training process and address all your questions. As we have already seen, the charging stations gather data on the energy demand from their customers. Each station uses this data to train and validate a local predictive model for its future energy demand. Once trained, each station shares its trained model with the rest of the network throughout peer-to-peer communication. The rest of the stations evaluate the quality of the received model with their own data. Throughout a consensus algorithm governed by the smart contract, all the nodes vote on whether to add this update to the global model. If the update is accepted, each node includes the model in its record. The locally validated models are federated to form a new, updated global model. On one hand, the local models, together with the updated global model and the smart contracts, are stored as data blocks. These blocks are permanently added to the blockchain ledger, becoming an immutable record. On the other hand, the updated global model is sent back to the charging stations after an evaluation regarding its implication in the network. Finally, the smart contract automatically executes, providing rewards or penalties to the stations that have sent the models. If their models are accepted, the station will receive better updates from the other nodes. If rejected, access to new updates will be blocked and a penalty will be imposed. Here you have the overview of the whole training process. This was just a quick overview of a fraction of Green capabilities. Visit our website or contact us for more information.
We introduce FedKit and demonstrates how it enables cross-platform federated learning for Android and iOS. Federated learning is a machine learning technique that enables edge devices to train a shared machine learning model while keeping training data local. In each training iteration, clients produce locally trained models. Then, the server aggregates these models into a combined model. Real-world cross-platform federated learning on smartphones faces many challenges, as demonstrated by the limitations of existing systems. For example, FedML and Project Florida lacks iOS support, and Flower has not supported cross-platform aggregation, so they have not achieved cross-platform federated learning on smartphones. On the other hand, Flower and Sift lacks machine learning operations support for production purposes. FedKit addresses these challenges by our model pipeline and custom federated learning workflow, which we demonstrate next. We demonstrate our system in action using 3 participants: a backend, an Android client, and an iOS client. We first demonstrate our cross-platform model pipeline by starting from a TensorFlow model. We convert it to TensorFlow Lite format using our TF-Lite converter, and convert it to CoreML format using CoreML tools. We then upload the models and model information to the backend. On the clients, we connect to the backend and train the model using unified training APIs. Because we carefully designed model conversion and training APIs, both clients produce model parameters in the same format, so the server can do cross-platform aggregation. While the clients are training, let's explain machine learning operations. It means that when a researcher develops a new machine learning model, they can deliver it to the client and have them start training it immediately. To demonstrate continuous model delivery, we change the MNIST model. We run through the model conversion process again, convert the TF-Lite model, record new model information, and we do the same with CoreML. Finally, we upload this model and its information to the backend. And that is the whole process to deploy a new model. Now, without even restarting, both clients prepare for the newly delivered model. This is enabled by our FL workflow. Our 2 clients just made a model request and got a new model from the backend. They then immediately enter FL server setup, and the backend spawns a new FL server as its subprocess. The clients then connect directly to this FL server for training the new model. This is our continuous FL training. The client apps did not need to be updated or even restarted to train newly deployed models. To summarize, we've highlighted our model pipeline that enabled cross-platform federated learning for Python-based model, and our federated learning workflow that enabled machine learning operations. Let's see our use case, FedCampus. It is an experiment using exercise data on university campus collected from smartwatches. We deploy an app. Within this app, we integrated FedKit to train a sleep efficiency prediction model across Android and iOS devices. And we leveraged machine learning operations with our self-hosted backend to iterate on the model in production. Finally, we're getting promising results in terms of the reducing loss. This FedCampus experiment demonstrates the real-world effectiveness of FedKit. That concludes our demonstration. Please see our GitHub repository for more information. Thank you, everyone.
Hello? Okay, we are gonna commence with the second session. Okay, please take your seats. We are gonna start now so we don't run out of time. Okay, so my name is Javier. I'm a research scientist. I think you saw me yesterday. I was talking about some of the initiatives, but today is not so much about me, but the next series of speakers. For the first speaker, I'm pleased to announce that Mohammed, who is a research scientist in Flower, and also one of our colleagues, Panhen, who is right here, is going to talk us about two super interesting features coming to Flower next. These are secure aggregation and differentiable privacy mods. So, if you are ready, here is Mohammed.
I'll wait for a couple of minutes for people to sit. All right, hello everyone. Welcome to this session. In this session, I and my colleague Pan will talk about our recent advancements in terms of security and privacy in Flower. The first part will be about differential privacy. I'll provide some motivation, and then I'll go over the definition of differential privacy. Then I'll explain about differential privacy in federated learning, and finally I'll show how you can use differential privacy in Flower. So the question is that is privacy really necessary in federated learning or not? Because in federated learning, there is no direct access to the data, and the data is also not being exchanged between the clients and the server. So it looks like everything should be fine, but that's not true. And the model updates that are being exchanged between the clients and the server can be the root cause of different privacy attacks. So the adversary can observe the model updates from the clients, or it can only monitor the output model to perform different kinds of privacy attacks, like membership, attribute inference, reconstruction, or model extraction attacks. And differential privacy is a prominent solution to provide privacy. And to put it simply, one mechanism is differentially private. When you apply this mechanism on one data set and you get the output, and then you add or remove a data sample from that data set, and you apply the same mechanism and you get another output, it guarantees that those outputs should be very similar. And same goes to the differential privacy in machine learning. So if you train a model on dataset and you get model M1, and then you add or remove one data point from that dataset and you train the model to get model M2, these two models should be indistinguishable to any adversary. And there are two main concepts in differential privacy. One is clipping and the other one is noising. So the clipping basically bounds the sensitivity, and the sensitivity is the maximum amount that the output can change when we add or remove a data point. It also mitigates the impact of outliers. And there are two variants of clipping that we focus on, fixed and adaptive clipping. And for the noising part, it just adds some calibrated noise to make the output indistinguishable. And for differential privacy in federated learning, we focus on two variants of central and local. And for central differential privacy, we assume that the server is responsible to perform the DP mechanism. And it does that by clipping the updates from the clients and then adding some amount of noise to the aggregated model. And for local differential privacy, each client is responsible to perform a DP mechanism. And the reason that we might use local differential privacy is that it doesn't trust server. So for central differential privacy in Flower, the noising part is always happening at the server side. And it also supports both fixed and adaptive clipping. And we also made it possible to perform the clipping either at the client or at the server side. So for instance, if you want to perform the clipping at the server side, you just need to use one of these wrapper classes around your strategy and then pass the hyperparameters for the DP part. And if you want to use central differential privacy with the client-side clipping, again, you need the wrapper classes for the noising part, but you also need to use the mods, which was introduced yesterday, one of those clipping mods to perform the clipping at the client side. And for local DP, you need to use obviously the local mods because the clipping and the noising parts are going to be applied on the client's updates before sending them to the server. Just to show how easy it is to use differential privacy in Flower. So before we had these strategies that you could create and use it for training. But now what you need to do is that you just use a wrapper around your strategy and then pass these DP hyperparameters. And this is for server-side clipping. So if you want to use the client-side clipping, in addition to those wrappers, you just need to pass the clipping mod to the mod attribute in client app. I highly suggest you to check the documentations in the Flower website. And now that we know how Flower is addressing privacy, let's see how it addresses security.
Oh, hi. Well, differential privacy is really a nice and decent technique to protect privacy. But however, as we all know, in reality, well, if you add some noises to the model parameters, it will inevitably impact the final performance. So if you're aiming for higher accuracy and you don't mind some slight overheads, then secure aggregation is for you. And now we are very happy to announce that secure aggregation is now officially supported in Flower. And I believe Mohammed has done a great job explaining why we need to protect the model parameters. And in this case, secure aggregation is to hide individual model updates from the server so that a curious server cannot infer anything from the individual client updates. Because while it is relatively hard to dig anything useful from an aggregate model because it contains lots of training data, but it is quite easy to dig something, well, basically to reconstruct the user level or say the sample level training data if the individual model updates is exposed to the curious server. So in secure aggregation, well, this is actually a brief but not very accurate overview of the secure aggregation. And here we have three famous clients, Alice, Bob, and Carol. And here, just for illustration purposes, we use pods of a digit 1 to represent model parameters. But please keep in mind that they are just illustrations. So the client model updates will not diverge as much in reality. And by no means it will really look like a digit 1. And what secure aggregation do is to allow each client to mask its local model updates with uniformly random noises. So the job of these noises is to make the masked model parameters completely indistinguishable from a random noise sequence, so that any third party cannot dig anything useful from this random thing. But also, the protocol allows that on the server side, the server can still able to, and only able to unmask the aggregate model parameters. So it can still get a very accurate complete digit 1 on the server side, but it cannot access individual client model updates. I just want to reiterate that these are visualizations of model parameters, and they don't really look like this in reality. And our secure aggregation implementation in Flower features three things, which is modularity, flexibility, and extensibility. And the first thing I would like to stress is the modularity. Unlike many other implementations, we go for a modular approach, which means it's very easy if you want to use the secure aggregation protocols with other stuff in Flower. For example, you can use it with local DP mode, the fixed clipping mode. And also, our design is compatible with all existing strategies, which means we can run the secure aggregation protocol with the federated averaging, and you can also work with central DP. But due to the very nature of secure aggregation, the strategists will not be able to have the full control of the aggregation process, so that some strategies might be compromised because of this. And the last thing is extensibility. In this design, you can actually implement your own secure aggregation protocols if you like. This facilitates some academic research needs. And also, in the future, if we release more secure aggregation protocols, you can easily switch to different protocols, just change a few lines of code within a minute, and within a few seconds if you type fast. So if you want to try out the SegApp Plus protocol in Flower, here's a code snippet, which is basically the code from Daniel's demo code. And we need to use the SegApp Plus workflow on the server app side, and also use the SegApp Plus mod in the client app. And you can see some protocol configurations here, and we included a complete and detailed docstring for the SegApp Plus workflow. So don't panic if you don't know how to configure the protocol. And for more details, you are also very welcome to try out our secure aggregation examples. And it is a simple example with 5 clients. And one of them is configured to drop out during the training to show that the secure aggregation protocol is robust to dropouts. And we also include a more detailed explanation of secure aggregation in this example. Sorry. We will continue working on this. And in the future, you can expect to see more variants of differential privacy. And the fast SegApp protocol, the light SegApp protocol, And we also plan to separate out the built-in quantization mechanism in the secure aggregation protocol, and so that you can free to choose whatever quantization algorithms you like. Well, that's pretty much everything we would like to share with you about differential privacy and secure. Well, any questions?
Great stuff. Thank you very much. So you spoke about the extensibility and the ability to stack with other modules and that kind of stuff. It seems to me that you're not going to be able to either at compile time and maybe not even at runtime catch or flag incompatibilities in terms of strategies. So perhaps there's a room there for some sort of, I don't know, a flower lint tool or something that you could actually run to say, hey, you probably shouldn't combine these things because it's not going to be a good result.
Thanks so much for the great question. Yeah, you're completely right. It is true that some strategies, especially those strategies, they want to access individual client model updates. They won't be compatible with the secure aggregation protocols. So we should actually flag something to know that, hey, they can't do this. But also, eventually, we do recommend to read carefully about the docstring of the secure workflow, because it also explains how the secure aggregation works under the hood, and also how you can expect from this protocol. So then you can know whether your strategy is compatible with the secure aggregation protocol itself. Thanks.
Okay, great answer. I think we are going to take one question from Michael, which is, he's joining us online. He's asking, what guarantee does central DP exactly provide in the context of FL?
Just to show in the bit, okay. So in central DP, it provides a guarantee that if we train the model with a bunch of clients, and then afterwards, and when we output the model, and then afterwards we train the model with, or like by adding or removing a client, and we output the model again, those two models are not going to leak any information about that specific client. So that's the guarantee that we get in central differential privacy.
Okay, cool. Great. Thank you very much for the introduction about the secure aggregation and DP mods in Flower. Our next speaker is Tim Hospedales. He's the head of Samsung AI Center in Cambridge, where he leads a team of highly specialized engineers and researchers doing research on topics like on-device AI, hardware to run the latest AI workloads, meta-learning, and of course, federated learning. He's also a professor in Edinburgh University, and he researches in topics like meta-learning and transfer learning as well. So looking forward to your talk.
Great, thanks a lot. Very happy to be here. Okay, so for this talk, I'd just like to give some big picture perspectives on where we're going in federated learning. So it's partially motivated by the contrast that I've seen in my roles working on FL in both industry and academic hats. And maybe I'll say something controversial or rash, but at least we can have some discussion, hopefully. Okay, so first of all, there are some things which are often flagged as FL challenges, but I've come to suspect might not be that serious challenges, especially in an industrial context. So let's talk about those first. So one thing you see in a lot of papers is some kind of figure like this that says, oh, here's my FL algorithm, and it performed almost as well as a centralized algorithm, and yeah, we are making progress. And that's kind of academically interesting, but if this is crucial for your business model, you are probably doing FL wrong. The whole point of FL is to make an unfair comparison because of accessing more data than the other guy, not be able to do FL equally well to centralized data on the same data. So yeah, you're probably doing it wrong if you're worrying about this. What else? A whole bunch of papers, including some of the talks in this summit, are worried about the impact of non-IID statistical heterogeneity on your model convergence and accuracy. Lots of people are worried about things like heterogeneous hardware. Lots of people are worried about comms cost. And maybe if I go out on a limb a little bit, I might say none of these things are really that big problems in some kind of industrial contexts. Why? Because nowadays we almost never need to learn a model from scratch. There is usually either some kind of foundation model you can start with, or you can pre-train some kind of model on whatever public data and use that to bootstrap your training. And then, depending on how good is your initial model, you can probably get away with only learning a subset of the parameters in the model when you actually go out to do your FL. And so what is the impact of this? Well, on the subject of non-IID statistical heterogeneity, there's a whole bunch of results now that show that this is a big problem when learning from scratch. But if you are fine-tuning a reasonably decent initial condition, it goes from a big problem to minor nuisance. So in this practical regime of not starting from scratch, we don't need to panic that much about non-IID, perhaps. And then coming to the comms cost, if we have a decent model to start with and we are only like refining a few parameters of it in our federated learning, then again, you can have orders of magnitude reduction in the comms cost because you are only transmitting a tiny fraction of the parameters in the whole model. This is a plot from one of the papers we did on this comms cost on x-axis, accuracy on y-axis. You can reduce a lot in this kind of parameter-efficient fine-tuning regime that we have already heard a little bit about in this conference. And finally, on the impact of heterogeneous hardware, everyone talks about this a lot, acts like it's a big problem, but I have seen so many good methods out there for different kinds of conditional computation that execute a kind of subset of the computation in a given neural network, and you can scale that computation up or down to address either hard instances, easy instances, or high capability clients or low capability clients. So maybe some of these things are not such crucial problems. Similarly, as we heard yesterday in the great talk from Borja, even not starting from scratch makes privacy guarantees a lot more practical. Because now if you don't start from scratch, you can do differential privacy learning, and it really works much better than how it interferes with your learning if you are starting from scratch. So again, many of the things people worry about a lot become kind of nuisances more than fatal problems, perhaps, if we are not starting from scratch. Okay. So that's some things which might not be severe problems. What are the things which are outstanding problems then? So challenges that are real bottlenecks. So one of the challenges is that at least for kind of cross-device learning in discriminative setting, which is what the vast majority of academic papers are about, they typically start off by doing something like training a CNN ConvNet to recognize CIFAR. That's kind of fine, but in reality for cross-device, you almost certainly don't have labels. So in any of your object recognition, object segmentation, detection, whatever it might be, you almost certainly don't have a label. So why are we spending 90% of our academic papers studying how to do FL in a supervised learning way, given that this is not going to happen in real life? So in the cross-device setting, basically, you are not going to have labels, and so we should be focusing on how to do federated, self-supervised, semi-supervised, unsupervised something. One of these are one of the things we ought to be doing, and I commend the minority of researchers who are working on this topic. I know some of you are here, but I think more of us need to get on this topic in order to really make FL a success. What else? Another thing that's a real challenge, I think, is most interesting things are non-stationary. So in the typical kind of academic paper benchmark, you have a data set, you pretend it's an FL data set, and you do your learning and you give some number. But in reality, the data distribution is always evolving. You know, during COVID, we had new kind of language and visual concepts emerging of face masks and whatever it might have been that we didn't have before that. And we need to keep up with this if we are really deploying things in practice. Even the meaning of emojis seems to change over time. You're not allowed to use these emojis anymore, and so on. So we have a lot of conditional concept drift going on. And again, there's a minority of people who are working on this stuff. I commend you. But basically, not as many people working on this as the severity of the problem if we really want to do FL in production on real problems and not toy benchmarks. What else? Another big problem, I think, is regulatory. So this can be maybe the biggest problem for deploying FL industrially in some kind of production system. So, I mean, I won't say much about this because I think there's going to be a great talk later that will delve into the details of this. But, you know, there's all kinds of problems that arise if you can't really control and inspect the data on each worker in your federated network. So hopefully we'll find out more how to deal with that later. And finally, there's the problem of bias and fairness. So having kind of fair and unbiased AI models is a very kind of topical challenge these days. This is actually a completely unsolved problem, even in central learning. People like to say that it's starting to be solved, but we had a slightly controversial negative result paper last year, iClear, that showed that it's definitely not solved. If you go to a federated learning setting where you have even less kind of data curation control than you do in a centralized learning setting, making sure that the models come out fair and unbiased is even harder. So those are some things that I think are kind of maybe the bigger challenges going forward than some of the popular ones, but less severe ones that I mentioned at the beginning. And finally, let me close by talking for a moment about federated learning opportunities. So where are the places where we can potentially make a transformative impact? So of course, throughout this summit, we've been hearing about diverse applications from healthcare to language processing and so on. And if we can really bring federated learning to bear on those applications, that will of course be a fantastic set of impacts. But just to step back a bit and think more broadly about whether there is a scope for federated learning to impact the foundations of AI. So coming back to the kind of opening point, federated learning should be about enabling radically unfair comparisons with regard to data and compute. And I think many people here probably agree with that. That might be the one less controversial thing I said. But we all just talk about it, but do we ever actually really do it? So what might we achieve if we actually really did it? So, of course, one of the things is the kind of popular foundation models these days, GPT, Stable Diffusion, take your pick. These are some of the topical things in AI, and they are mainly based on unprecedented amounts of data and compute being thrown into existing algorithms. So what about a future where we can arrive to the next generation of these kind of systems by leveraging federated learning to leapfrog them in terms of the amount of data and compute that we can throw at building the next generation language model or whatever it might be? Also today, we are mainly using neural architectures like convnets and transformers that were designed by various smart engineers. And there's a whole sub-discipline of neural architecture search that aims to compete with them through automated discovery of new architectures, which is great, and they have some cool outcomes. But I have not really seen anybody abandoning the hand-engineered ones for the automated neural architecture developments in a widespread way in practice, which I guess is because they are not that much better than the hand-engineered ones, only marginally better. But what about a future where we can really leverage the unfair advantage in data and compute provided by FL to really do federated neural architecture search and kind of decisively come up with a better architecture beyond the next transformer or whatever it might be? And finally, one of my pet topics is optimizer meta-learning. So again, in our daily lives, we probably use optimizers like Adam and SGDM and whatnot. Despite that there is a whole very active sub-discipline of optimizer meta-learning. And similarly to this neural architecture search story, these guys have derived better optimizers that can beat Adam and so on in some cases, but not enough better that people are widely abandoning Adam for kind of machine-designed optimizers. But again, what if we can leverage the unprecedented data and compute of FL to really rock the foundations of AI by having a dramatically better optimizer? That would be another really cool outcome that maybe we can discuss in some future iteration of this summit. And yeah, I'll leave it at that. Thank you.
Okay, so we have a couple of minutes for questions. One question here.
So actually, I have a question regarding fairness, that how we can solve the problem of fairness, because it is a very serious problem. Because the thing is that humans are biased.
Yes.
And because humans are biased, data is biased. And because data is biased, my model will be biased. And if my model will be biased, maybe it will amplify the bias in the maybe next model or maybe new models. So how we can solve the problem of the fairness practically?
Yeah. So yeah, that's a super good and very difficult question. I was saying this is actually still pretty much unsolved even in centralized learning, so before we get to the added challenge of federated learning. But I think one interesting insight about that recently in the centralized learning area is that if you, the key thing is to optimize for the fairness on a validation set and not on a training set. Because anyway, if you do deep learning, you can fit your training data perfectly. It will have same accuracy for men, women, or whatever other aspect of fairness that you are trying to address. And the unfairness arises during validation, not during training. So you should do your hyperparameter optimization with regard to validation data, the fairness of predictions on validation data.
Thank you, Prof. Actually, I have a simple question. Can you give us a recipe whether a project should be implemented in the federated learning environment or a centralized environment?
I mean, I think that's what we've been talking about for the whole summit, right? So when your data is distributed around the world and policy or technical reasons prevent you from aggregating it, or when you just don't even have enough capacity to process it centrally, these might be the times when we want to consider FL, right?
Thank you so much for a great talk. I just have a question regarding starting from scratch.
Yes.
It's true that we don't start from scratch for image, text, video, but what about modalities that we don't have data, like PPG, EEG, biosignals, where we can find good model for those if we don't do federation?
Sure. So, I mean, I agree for some cases it's easier than others, but even for something like EEG, there is some open source EEG data, even if not a lot like in images. And so even if you start from a not very good model, it's still a lot easier than the statistical challenges you get with FL starting completely from scratch. And then for things like EEG, which you can think about as time series, there are time series foundation models and so on that you can start with before doing federated fine-tuning potentially on an EEG task.
Hello. Given the very applied nature of your research, have you looked at the intersection of like co-designing algorithms and with systems that operate well together? So let's say you have highly distributed data, you'd obviously have distributed servers, communication in different parts of the world, different speeds, etc. So have you considered looking at this sort of intersection of systems and optimization in this sense?
Yeah, that's one of the main topics of Samsung AI in Cambridge. Yes.
Have you found anything interesting as direction?
Oh gosh, found anything interesting? Yeah, so we do some things like kind of looking at hardware designs that will better support particular kind of neural architectures. Yeah, so I can't say too much about it, but it's one of the very active topics in Samsung, yeah.
Thank you.
Okay, I think we are right on time, so thank you very much for the great talk. Our next speaker is joining us remotely. She's Sherry Ding, is a senior artificial intelligence and machine learning specialist, solution architect at AWS. And today she's going to tell us how she uses Flower in Amazon SageMaker. Hello, Sherry. Can you hear us?
Yeah. Yes, I can hear you.
Okay, great. Then the floor is yours. Go ahead.
Yeah. Thank you. So good afternoon, everyone, or good morning, based upon where you are located. Like me, I'm in US East. I'm Sherry Ding, a senior AI ML specialist solutions architect at AWS. I mainly work with our customers to help them develop and migrate machine learning workloads on AWS cloud. So today, I'm gonna share with you like how we use Flower package to implement federated learning on Amazon SageMaker. So federated learning is a machine learning approach that allows for multiple separate training sessions running in parallel across large boundaries. And these large boundaries, it can be geographic boundaries. and then aggregates the results during the training process to build a generalized model, or we call this a global model. So when we put federated learning on the cloud, the training usually occurs in multiple separate accounts or across regions. And each account or region has its own training instances. And the training data, it is always decentralized from the beginning to the end. So this characteristic of decentralized data all the time from the beginning to the end allows federated learning to solve challenges related to data privacy and scalability. In those scenarios, like we're sharing data, it's not possible. So we do have customers, especially customers from government agencies or healthcare institutes, that they want to leverage bigger data sets from other agencies, other organizations to get a more generalized model. But however, data sharing is not allowed usually in between these agencies. So in this type of scenarios, in this type of use case, federated learning is a perfect fit. When we consider like what type of federated learning framework or package that we should choose for the use case, usually we need to consider like what type of model category does it support, or what machine learning framework it supports. For example, does it support a general data size package like scikit-learn? Does it support TensorFlow, Hugging Face, or PyTorch? And does it require a specific device or operating system for a package? But when we consider to put a package in the cloud, there are some other like extra considerations. For example, the package's extensibility. Can it fit the scalability of the computing resources on the cloud? Or is the package size too heavy to install it onto the computer resources in the cloud? So based upon all these considerations, we chose Flower because it is an easily extensible, customizable, and a lightweight framework for the federated learning on the cloud. To do federated learning on the cloud, as I mentioned before, usually the training process happens across regions or in different accounts. So what we need to do, like in network setting part, first those computing process, they happen in VPCs. So here VPC, if you haven't heard this word before, VPC stands for Virtual Private Cloud. So Amazon VPC gives you full control over your virtual networking environment, including resource placement, connectivity, and security. So after we place the training resources in different VPCs, we need to do a VPC peering, this technique, to make sure these two VPC networks, they can talk to each other. So a VPC peering connection is a networking connection between two VPCs, which enables you to route traffic between these VPCs using private IPv4 or IPv6 addresses. And the instances in either VPC can communicate with each other just as if they are within the same network. So this is the networking side that we need to set up to do federated learning in the cloud. And with regard to the platform to do the implementation, we use Amazon SageMaker, our managed machine learning service that makes it easy for machine learning developers to build, train, and deploy machine learning models at scale. So Amazon SageMaker provides two types of notebooks. One's called the Studio Notebooks. These notebooks are quick start collaborative notebooks that integrated with a lot of purpose-built machine learning tools. And another type of notebook, we call it notebook instances. So these notebook instances, they are standalone, fully managed Jupyter notebook instances in the Amazon SageMaker console. So to implement federated learning, we have to use notebook instances. Basically, SageMaker notebook instance, it provides you like a familiar Jupyter notebook application through a fully managed machine learning Amazon EC2 instances. And the notebook instance, it has a variety of networking configurations available to it. In our federated learning setup, we have the notebook instance run within a private subnet of the VPC and don't have direct internet access. So here's the large notebook instances in VPCs. Okay, after we have figured out all this background information, I'd say, then here's a full architecture of setting up federated learning on SageMaker with Flower package. So first we set up 2 accounts. One is the server account, the other is the client account. These are AWS accounts. And in each account, we launched a VPC, virtual private cloud. And inside the VPC, we launched a SageMaker notebook instance. So in the client, and we also did the VPC peering via the private subnet, where the SageMaker notebook instances are launched. So in the client account, the SageMaker notebook instance, basically we implement the federated learning client that trains a local model using a local data set. The local data sits in S3 bucket. That's the common location for SageMaker training process. We put the data in S3 bucket. And thus in the client account, so the federated learning client trains on local data to get a local model and send back the model parameters to the server account via the VPC peering. And then in the server account, so this is a federated learning server where that server sits. So basically in this account, the server sets the strategy for the federated learning, like the strategy for the weight aggregation, right? And it does the global evaluation using a separate like global data set, a separate data set to evaluate the global model and generate a final accuracy matrices. All right, so after that, there are a couple of like implementations that we have to do. So one is about after we set up the VPC, did the VPC peering, launch a notebook instance in each VPC. Next implementation is about we need to configure cross-account access setting. So cross-account access settings, basically it delegates access from the server account to the client account by using IAM roles. So we created an IAM role in the client account that allows the server account to kick off the training process, to start the training process, to stop the training access. But the client account doesn't have access to the data or see the output of the training process because in the IAM role, we define the policies like what type of actions the server account actually can do. Okay, after we define this IAM role in the client account, then in the server account, we grant access to this IAM role in the server account. Then in client account, of course, we need to implement a federated learning client using Flower package. And in the server account, we implement a federated learning server, same using Flower package. Then when we start the training process, first we assume the IAM role to the server account to run the training job, to kick off the training job in the client account. And then the server account, it aggregates local models, weights into a global model, and during the process, and it do testing during the process to get the global accuracy matrices. And I know it's kind of a rough walkthrough of the implementation, and for detailed implementation, please scan the QR code to read our AWS blog. So we have detailed implementation in the blog together with our code samples in our AWS samples Git repo. Please scan the QR code to get this information. All right, that's pretty much about it. And thank you for your time. I'm happy to take any questions.
Okay, thank you. Thank you, Sherry. Are there any questions in the audience, from the audience? Okay. Well, while you think for a question, I have one question for you. Can you tell us a bit of, for example, what type of data modalities do you see federated learning being used more often, at least maybe from the projects you have been involved? Do you see images being more popular, other type of data? Can you share something?
The customer that I work with on this project, it's basically the tabular data set to generate regression models, classification regression models. And I've also seen some about using image data, like using the PyTorch package.
Okay. Thank you.
But I'd say most of those customers, those agencies, they dealt with more like a tabular data set to implement the federated learning.
Okay, very interesting. I see there are no questions currently. I don't know if there are questions online. No questions. So I think thank you very much for your time and your fantastic presentation. Thank you.
Thanks all. Thank you for having me. All right.
So our next speaker is Roman Brehehoft. He's a machine learning engineer from Zama. It's I believe, a company, a startup based in Paris, and they do a fantastic homomorphic encryption product. So he's going to tell us everything about it and what it makes, why it makes sense to use it in the context of federated learning.
Yeah. So, hello everyone. My name is indeed Roman Brehehoft. I'm a machine learning engineer at Zama, and more specifically in the Concrete ML team. So today I'm going to present how to combine fully homomorphic encryption with federated learning for private inference. So, what does fully homomorphic encryption, and I will explain what it is afterwards, have in common with federated learning? Well, obviously, it's going to be privacy, data security. As you all know, of course, Flower enables federated learning, offers a way to use federated learning for private training. But that's not the only way we can add privacy on such use cases. We also have some concerns on the inference phase. Using private inference with fully homomorphic encryption, we can add this new layer of security that I will explain. We actually heard a bit of talks yesterday. If you've been there, we talked about differential privacy when we deploy models. So this is somewhat linked with what I'm going to explain. But basically, here, I'm going to present our tool, Concrete ML, which is built by Zama. Everything you're going to see is actually open source, so you can actually see what we've done and try to use it. And it's compatible with federated learning. So yeah, let's dive in. What is actually fully homomorphic encryption? So those who don't really know what it is, let's take a simple example with a centralized server. You have a client side and a server side, where the client side has a user that wants to benefit from a service that wants to use a machine learning model inference for any kind of thing you want. This user has some data. Usually today, the thing is that this user is going to encrypt the data and send it to the server, but this encryption is only going to last for the transportation of the data. Because for now, usually the server decrypts the data to be able to run the model on the server side, and then once the output is created, it's again encrypted and send it back to the user so that the user can decrypt it and read it. I mean, obviously, there are some problems with that, and I'm not going to explain a bit more about that, but I mean, there's a few and quite a lot, privacy and security concerns about that. I mean, the user here doesn't have any control on his own data. The server can actually do whatever he wants with that. So the idea is that we want to leverage that and make sure that the client is the only party that has access and control over its own data. So one of the solutions we offer, of course, it's fully homomorphic encryption, or FHE. The idea is that you take this similar example. A user still has some data. It's encrypted, it's sent to the server, but this time the most important part about that is that the server does not need to decrypt the data. The model can be run and evaluated on the server side without ever knowing what the data was, or even the intermediary values or the output. The output is sent back to the user, and the user can decrypt it and read it as well. So it's really important to understand that here the user is the only person that has access and control the data. No other party can know about it. For those who knows a bit about homomorphic encryption, fully homomorphic encryption actually handles any kind of operation. So not only additions and multiplications, but also non-linear operation. And that's a pretty good feat about that. Let's talk a bit about our tool, ConcreteML. The idea is to use this FHE principle and bring it to the machine learning world. So we started a bit on the centralized idea, and we started to be interested more and more in the decentralized and with federated learning situation. ConcreteML is built on common used and well-known libraries and frameworks. So we have PyTorch, scikit-learn, TensorFlow. We are built on the ONNX framework as well. We provide support for these kind of models, so well-known models as tree-based models, linear models, neural networks as well. For those who knows a bit about homomorphic encryption, for the past few years, the main drawbacks was that there's some kind of computational overhead. Computation can be a bit slower than what we are used to, but be sure that in this case, we are improving things. We are starting to get, we are actually ready for production for tree-based models where inference can get around hundreds of milliseconds per inference. For linear models, it's even faster. We can think about 10 milliseconds per inference. So it's improving more and more. And I'm not even talking about some works that is done on hardware acceleration that we or other companies do. So yeah, keep in mind that fully homomorphic encryption is improving more and more and are already doable in production. Neural networks is a bit more complicated, but it's already doable, so there's quite some nice works about that. Something that is also, of course, interesting here is that these models are complementary with Flower. I'm going to show you how afterwards, but each one of them is able to be used, to be trained with Flower and then loaded in ConcreteML. But before that, just let me show you a bit how the API works on ConcreteML. So if you know about scikit-learn, it's very similar to what any data scientists are used to. So here are a few examples for logistic regression or XGBoost classifier. There's a few parameters more than that. You will have to compile your model after training it. But basically, you get the idea. It's very simple. There's no need to know about any cryptographic knowledge. We are mostly based on data science stuff. The crypto knowledge is optimized under the hood. And also we provide some tools to develop and debug with like some simulation for FHE computations, but of course you can execute using FHE as well. Talking about Flower, how can we use this API and combine Flower with ConcreteML? So again, all the examples you're going to see are accessible on our GitHub repository, so it's all accessible and you can try it on your own. So here is an example where you have already trained your model, or at least the last part is the server side, where you train your model using Flower with a logistic regression scikit-learn model. Once your server has trained, well, it's very simple. It's using a one-liner. You can load the model directly in ConcreteML, as seen here. As I said, you need to compile it afterwards. And that's pretty much it. You basically have a ConcreteML model, and you save the necessary files for production, but that's it. Then you are able to use it for private inference in ConcreteML. Just to show how it works, that's a way to do it. It's simplified, of course, but here's the typical setting I was explaining before. You have a client side, so here the client side is really when you deploy your model, it's during the inference phase, I insist. So the client side is really the client, the user that has data that wants to benefit from the server's inference, and that will send only encrypted data. So the client side here only needs to first generate private keys that is needed for the evaluation, and then, of course, encrypt the inputs that it wants to use. Once this is sent to the server uses that, runs the inference, and then sends the encrypted outputs to the client. And afterwards, the client receives this encrypted output, the output can be decrypted, and the user has his result. What can actually FHE bring to federated learning model? Well, as I explained first, it's private inference, but why would you do private inference for that? I mean, we've talked a bit about that today, actually, with yesterday for differential privacy, for example. There's some issues where, well, the model parameters can be misused, or can be, there's some attacks where having access to the model parameters can be very bad for any kind of attacks like inversion models or stuff like that. Keep in mind that using private inference with FHE, the model parameters stays on the server. There's no need to deploy the model parameters to any clients when you are in the inference phase. So that's why. There's also an idea of intellectual property. In some cases, the server or the one that owns the model doesn't want to deploy all the parameters to all client parties, so they can keep it on the server side and then just ask for user to send encrypted data, and that's it. Of course, we talked about it today, secure aggregation, fully homomorphic can be used for that. Basically, one of the things that FHE can add to that is that it, as I said before, it allows to compute any kind of operations, so not only additions, but also any nonlinear operations. So that's very interesting to it. This is not possible with ConcreteML for now, because it requires some collaborative tools today, and we are working on it for now. But it's an interesting property, and we are delighted to talk about it more afterwards. And there's actually a good paper just here talking about secure aggregation with fully homomorphic encryption as well, so feel free to check it out as well. But going back to ConcreteML, so as I said, we are focusing on inference, private inference, but not only. We have also works for secure collaboration, so secure aggregation could be one of them, but we can generalize this to any kind of situations where you have multi-party that wants to well, work together without actually sharing the data. So it's more of a generalized thing about that, so very interesting stuff. We already had some work with private training. So here is really training a model. So we have examples with logistic regression where the weights are also encrypted, not only the data, but the weights as well. So it's an ongoing work as well. And finally, we work a bit with large language models because it's, of course, a hot topic. And we provide some kind of hybrid solutions that can actually bring some IP protection as well. So if you're interested, of course, I invite you to check out our Hugging Face spaces or our examples found in the repository. So yeah, again, feel free to check out our repository at Zama on GitHub. Also, you can ask us questions on the fhe.org server. And yeah, thanks a lot, and feel free to ask some questions.
Thank you, Robin, for the great talk. I think we have a question over there. I'll run.
Thanks very much for the interesting talk. So have you thought how to extend it to multi-client setting? Because in the example you mentioned, there's one client. It can generate the key itself, but in the case where we have got multiple clients, then they can't share the keys easily, and even if they share the keys, they can collude with the server, and as you know, we're going to have problems. And we won't have any privacy unless you use multi-key, fully homomorphic encryption, which is very computationally expensive. So have you thought about how to extend that?
So for collaborative computations, as I said, we are still working on it. There is, with fully homomorphic encryption, what we call threshold decryption. That enables multi-party and key sharing, and then when the result is also going to be shared as well. I cannot explain more about it because it's still ongoing, and I'm more on the machine learning part. But feel free to reach out to us and to know more about that, because we have already some blogs and people that would more be expert on that subject. But it's definitely interesting, and it's something that we are currently working on. Yeah.
Yes, and I have questions, or may I ask? Or
yeah, go ahead.
So can you also apply this technique to the image or type of the data, or is there some limitations?
Sorry, can you repeat?
Yeah, so can you apply this technique to all type of the data, or maybe mainly for tablet data, or it's not limited?
It's basically, so it can be done on many kind of data. To be a bit more technical, the scheme, the encrypted FHE scheme that we use under the hood uses integers, but we also use floating points using quantization to handle that, and it works really well. But any kind of data where you can, if you like, I don't know, if you want strings, for example, you can map with integers, and it's a way to use these. So basically, I could say that, yeah, you can pretty much handle any kind of data using FHE. It's a general thing to do, yeah.
Because one of the concerns is actually apply on the data, and the server actually encrypt the data, right? But when I think about simple CNN and classification with the image, if you think about adversarial the attack, when adding a little bit the error, then it should actually classify like a dog, but maybe it's set like a non-dog, and then so maybe can actually affect in the performance. So that's why I'm asking the questions, any performance drop, maybe can be in a server size and in inference time, maybe it might be hard to distinguish whether it's got some attack by adversarial attack or apply with this technique. So, but maybe, yeah. So
I think maybe the question is related to some type of numerical degradation involved during the encryption process.
What I can say is with fully homomorphic encryption is that computations are exact compared, for example, for differential privacy, where you have some noise and stuff like that. With full FHE, everything is exact, so there is no differences with the actual computations that you want in the non-privacy settings. Maybe I'm not sure we can talk about it. Maybe I'm not sure I understood the question, but you talk about CNNs or with image classifications. Yeah. We already have a lot of examples with that, and it works pretty well. So maybe I can share some examples to you with that.
Thank you.
Thank you. Does it support different activation functions like ReLU and all?
Yeah, so...
because it is tough to approximate them in FHE, and they get errors along with them. So approximation in FHE, yeah.
So basically, the beauty of the scheme that we use for FHE is that we handle any kind of operations, including non-linear ones, like machine learning activations, like ReLU, of course, in an exact way. We do not do approximate computations. It's all exact. And that's why we are working on that, because it's really interesting to do that.
How it can be in exact way? Can you?
If you want the cryptographic details about that, I mean, I can forward you some expert on that. I'm not a crypto expert here, but mathematically, it's. I mean, if you want to check it out, it's you can check out our website, of course. But it's the TFHE scheme. That's the one we use that enables that. So yeah.
Okay, so if there are no more questions, let's thank Roman again for a great talk.
Okay, so we've got a really interesting next session. We're going to change the format up slightly to make it a little bit of a change of pace for you all. We listened to a lot of slides. We're going to dive into a topic that's really important. It's in the area of FL, Federated Learning, and AI regulation. We're going to take on one of the topics that Tim asked us to really dive into, and so we've taken on board this, this challenge and found for you two experts in this area. Let me introduce them to you. The whole idea here is to make it interactive. So while I'm speaking, start thinking. And so think of a few questions, what you want to know. We're going to look at this AI regulation space. Let me introduce these two people. So right down here we have Bill Marino. He is a non-practicing lawyer. He is a visiting lecturer at Cornell. He is a startup founder and spent 5 years doing tech at Adobe. And currently, he is studying for a PhD in AI at the University of Cambridge. So thank you, Bill, for joining us. We also are joined here by Charles Kerrigan. He is a partner in the finance team and part of the specialist crypto and digital assets team in CMS London. And they specialize in emerging technology, including crypto, digital assets, but also decentralized AI and finance. And he's a very modest man. I saw this amazing quote about him. It's from Legal 500. They say that Charles is a creative, but risk alert and practical lawyer. So I think you want all those ingredients all in one person. So with that as an introduction, I think we can kick things off while you still are thinking of things you want to know. And so I'd invite them to maybe just give us a bit of a landscape. So even before we dive into these subtopics of AI regulation, could you both speak to things such as what is the EU AI Act? Let's spend a couple of minutes, 2 or 3 minutes, explaining it at a high level and discussing the risk topics and so on, all the major kind of things that kind of lay the landscape for questions that I'm sure people in the room want to know about.
Yes, thank you so much, Nick. Are you going to join us, Feather? Are you going to sit?
No, I'm just gonna. Yeah.
So with Charles's assistance, we thought I would open up and just sort of talk about the EU AI Act and what is it, at a super high level. I think this is probably something that anyone who's going to be putting things on the EU market anytime soon or might be creating models that are downstream going to be put on the market in the EU will want to know about. So at a very high level, this was just ratified by part of the EU. This was just passed, I should say, this week, 2 days ago. So this is hot off the press. They ratified the text of the act. So it looks like it's probably coming later this year. We'll start to see it go into effect. Is all of that accurate, Charles?
It is. That's right.
Okay.
It's brand new, but we've seen it coming for 3 or 4 years. So we're pretty well used to it.
Okay, great. So at a very high level, This applies to, this sort of slices and dices the world of AI in a couple different ways, but there's really two, I think, key paradigms that everyone ought to know. And one is AI systems. And I do have the definition on my phone, so I don't mess this up. But the way AI systems are defined are, let me see, there's a lot of definitions in this act. So get ready for all of those.
And it's not the only definition of AI. Every standards body, every regulator has got their own. But this one will probably become more important through more use and reference than others.
Absolutely. So the way it defines AI systems at a very high level is machine-based systems that are designed to operate with varying levels of autonomy, and that take some input and then infer some output, such as a recommendation or a prediction. So that's AI systems.
I think one point I always make in this when we're having this conversation is the definition. So regulation is written broadly so that people can't game it. And often it's written in overbroad sense. And there was a lot of debate around this. But you guys would see this definition and think, well, it sounds a lot like algorithms without much learning in them. So this is a very broad regulation. It's coming for algorithms that have self-improving characteristics, but it's wider than that.
So it goes beyond machine learning per se. Okay, say. So with AI systems, and we're going to talk about the other paradigm, which is general purpose AI in a second, but with AI systems, the key kind of thing that you need to know is that they slice and dice these according to risk level, with the riskiest being prohibited. And these are things like manipulative systems. So those are just, cannot do them. And then there's high-risk systems. And this includes safety features of products that are already regulated in the EU, systems that are themselves products that are regulated in the EU, but also items, or I should say use cases from a list that are clearly specified as being high risk. And this includes things like education, chime in with a couple others, critical infrastructure.
Exactly, yeah.
And so these are the subject of a lot of the rules in the Act. These are, you could say highly regulated maybe. And there's a lot of rules around data governance, human oversight, documentation, technical documentation, and a number of other requirements. The other paradigm, and I'll mention briefly, and then we'll say a couple other things and maybe get into it. I'm sorry this part is taking so long, but hopefully this is very good background for everybody. You're definitely going to be hearing a lot more about this. Is general purpose AI. So most of us would call this foundational models, right? So this is models that have a wide variety of downstream use cases, broad applicability. And these are, again, kind of divided into just general purpose AI and then general purpose AI with systematic risk. And this is kind of, in my opinion, muddily defined, but this is, systems with higher impact based on benchmarks. The amount of compute that it took to train the system is one thing you can look at to decide whether or not it falls into this category. And so, between the two kind of buckets I just described, obviously the latter bucket is a little bit more heavily regulated. When it comes to general purpose AI systems, a lot of the rules are around documentation, transparency. Important exceptions in the Act. Research and development is an exception. So this is mostly about things that are on the market, being used commercially. So that's obviously relevant to a lot of the people in this room. And then open source has sort of a semi-exception, right? I think, correct me if I'm wrong here, but open source, the rules do not apply unless you are high risk or unless you are, you have systematic risk in the case of general purpose AI. Yeah. So that's very high level. Most of these rules are like the responsibility is borne by the model providers, which is a way of saying the model developers. But the downstream users, like fine-tuners, can become developers, and therefore the onus is on them. Anything else you would want to add at a high level?
No, I think you've got it exactly right. So a jurisprudence point here, regulation, it bans things, or it permits things subject to conditions, or it prevents some kind of people from using the thing and other kind of people can use it. So this is really significant. Bill's kind of laid it out, and I think the bits that I would echo here, this is EU regulation. So we do a quick poll. Who's from the EU? Lots of hands, okay. So you won't be surprised if I tell you that this is pro-consumer more than pro-innovation, where they strike the balance. So you know where regulators are coming from, because there's a culture to the regulator and to the environment. So human dignity is a very significant piece of the policy behind this, and human in the loop is another significant piece of the policy behind it. Does anyone work in a regulated industry? I wasn't sure many hands would go. So not many, but some.
There's a guy down there who does insurance.
Okay.
We've got a doctor here. I'm not sure. What industry is this? So finance. Okay, got you. Okay.
So Nick has found some people who, if it's not coming through on the mic for the streaming, are subject to financial regulation and medical regulation and similar. So there's a run-up to the EU Act. We've got almost a couple of years to prepare for it, but at that point, you're all subject to regulation. Working in a regulated industry is not like working in an unregulated industry, because you have the shadow of the regulation on everything that you're doing. It's like the regulator is looking over your shoulder. Whatever you're building, you have to take account of the regulator's view of that, the regulation's view of it. Because if you develop the most valuable tool imaginable, but the regulation prevents you from deploying it, then it's a fantastic theoretical project, but you can't have any customers.
To that, I would also add, if you develop something in the lab, as cool as it is, once it crosses over to downstream users who are going to try to productionize it, it's going to be subject to these rules, right? And that's, yeah, pretty intense.
Yeah.
So so then I think now we have a pretty good background. If you hadn't sort of looked into what the EU AI Act is, that's sort of a landscape sort of a view of it. And one of the reasons why we're so interested in it is that it's probably going to be a precursor to other types of regulation that might evolve in other jurisdictions, the US, China, and so forth. And so are there any immediate questions that people want to jump in on? And then we've got a couple of positions that both the gentlemen want to take. But let's just take a couple of quick questions.
I saw that hand first, and then maybe.
Let's go to Connor first. Wait for the mic.
Thank you. I was wondering if anything related to unlearning was in the act, unwinding models from having certain people's data.
I could take that unless you want to jump. Well, quickly, what I'll say, one thing I didn't mention in the overview is this this does not disrupt any existing regulation like GDPR. This coexists with it, right? So I think of unlearning as something that was heavily driven by GDPR and other data privacy rules. So everything in this act has to coexist with that. I'm not aware of anything new in the unlearning space. That certainly could happen. I haven't seen anyone talking about it. But just a heads up, everything in GDPR still applies. So unlearning for the purposes of satisfying GDPR would still apply to everything being done here.
Exactly. I think it's your job to fix that stuff. So the regulator's not going to tell you what to do or how you should do things. So it's looking at the outcomes, because that kind of thing is what affects the users, and it's the thing that the regulators from a non-technical perspective can figure out. So as Bill says when he lays out the Act, the main provisions of the Act are identifying systems that are within the perimeter of the Act and then putting a risk classification over the top of them. So the practical effect of your question is, if you built a model using data that it was not legitimate to use, then you've got to retrain the model or junk the model. So the potential cost of ingesting data that is not permitted is enormous. And that's the piece from the investor perspective that we're particularly focused in, that people aren't investing into models that are going to be shut down and therefore valueless.
There's a gentleman in the blue. He had his hand up too. She's almost there. Otherwise, online can't hear.
So my question is, maybe can you explain a bit with the use case, like for example, like ChatGPT, which is actually developed in the US, and then we don't know actually what kind of training data actually they use. Maybe they didn't expose actually really fully the transparent, and it's still like controversy whether they actually have to be transparent for everything or not. And then how this EU AI Act might affect, like in EU, like here, for example, maybe in 1 or 2 years, maybe I cannot use the ChatGPT, or I don't know, like, have you thought about it, or?
That might be a good segue into this.
Yeah, okay, so I think we can address some of these topics actually just in a couple of positions we're going to introduce. So, Bill, do you want to just speak to your first position that you wanted to explain?
Sure, thank you. And I promise you I'm going to respond to that while I'm talking about this. Thank you for that question. So I've spent a lot of time over the last couple months looking at the impact of this EU AI Act, specifically on federated learning. And we do, just spoiler alert there, we do have a paper that we put up on Archive that looks at this topic. Please check that out. At a high level, I would say there's a little bit of a conundrum. And when I describe this federated learning conundrum, I think you'll find that a lot of it also applies to other closed data scenarios, like, whether you use, Llama 2 or the OpenAI models, okay. So here's the conundrum I'm talking about. I think, and Charles, I'm very interested in your thoughts on this as well. So the Act, certainly in its preamble or its recitals, which as a US trained attorney, I'm a little less familiar with. I don't think they're binding, but they kind of give you some context that could be become influential on later court decisions. But they make a big deal out of privacy. It's one of the 7 pillars of responsible AI that the Act is built around. And I even think in there's sort of an endorsement of systems like federated learning that help preserve privacy. So I know there's a lot of text right here. I'm going to read it because I think it's really important. This is in the recitals. And as I'm reading it, just think about how it applies to federated learning. It really does sort of sound like an endorsement of federated learning, but also a statement that the rules that apply to everyone else also apply to federated learning. The right to privacy and the protection of personal data must be guaranteed through the entire life cycle of the AI system. The principles of data minimization and data protection are applicable when personal data are processed. Hopefully everyone is familiar with personal data, protected in many other parts of the EU legislation. Measures taken by providers to ensure compliance with those principles may include technology that permits algorithms to be brought to the data and allows training of AI systems without the transmission of the raw or structured data. Sounds a lot like federated learning to me. Might fall in there. Without prejudice, however, to the requirements on data governance provided for in this regulation. So I read that last part as saying the same rules apply despite this sort of endorsements. And with that being said, so we sort of have this kind of endorsement, certainly of privacy and maybe of systems like federated learning that protect privacy by design. But then there's a lot of rules, and I think some of these we're going to have to all spend a lot of time thinking through how we make this work for systems like federated learning. And I'll be quick, and I'll just highlight 2 sort of buckets of rules. One is around training data. So the EU AI Act subjects training data to a number of requirements. Those have to do with training data governance, which has to be appropriate in various ways. Training data quality, so that the training data has to be everything from relevant to complete in light of the purpose. It has to have the right representation. It has to be free of errors. It has to be free of data poisoning. So there's a lot of requirements around the training data itself. And that's all for high-risk AI systems. For general purpose AI models, it has to be documented. So, we all have to think, what does this mean in a federated learning scenario where the data is closed off to us by design? I think we all have to think about ways that we can capture data, information, I should say, about data governance, about the data quality, client side, and maybe pass that back to the central server in order to stay compliant with something like this, with a regulation like this. I'll highlight one other sort of interesting set of rules, or in this case, it's more like forthcoming rules. The Act commands some EU entities to work on energy efficiency rules. So these are kind of kicked down the road a little bit. We don't know what these are just yet until these entities refine them. But we could be looking at a world where there are energy efficiency standards. And similar to the situation with training data, it's fairly straightforward, perhaps in a centralized setting. But when you're talking about a federated setting where we have many different devices that are consuming energy in different ways, first of all, how can we measure energy efficiency on those devices? We'll have to have a framework for that. And then based on the standards as they come out, how do we satisfy them? How do we make these systems more energy efficient client side? So those are sort of, that's the conundrum that I would highlight. This endorsement of privacy, federated learning to some degree perhaps, but also maybe some hurdles that the research community has to think about technical solutions for.
Great, great. I think there might be a couple of questions in the room about this. Ruth, there was 2 questions just down here from these 2 gentlemen. I think one's on insurance and one I'm not sure what it's on, but I think it could be quite relevant. Let's see where we go with it. The mic's just coming over.
Yeah, my question is really more on the policing. So the EU AI Act exists for EU companies. What do you see, Charles, as the mechanism by which they're going to enforce it? And what do machine learning engineers and everybody else need to put into their code, into their documentation, into data governance and management and all the other stuff to be able to comply with the EU AI Act if they come after you?
That's a great question, and it's not a plant, although we do know each other. So I didn't know he was going to ask that. So broadly, this is, from our perspective, like how's it going to be enforced is a question for the regulators. They've got regulation, they've got courts. You can't determine, the bill's saying, we've got language here, and it can be interpreted different ways, particularly because it's all fact-dependent. So you would take your models or your systems, whatever you're building, all of these amazing things that are printed up around the building, and you apply the regulation as a framework across it. So the regulation is not responding to what you're building. It sits as a framework for you to interpret in relation to what you're building. Enforcement action can be brought by the regulators, but you'd find out if you have a difference of opinion on the terms of the regulation, you think that you've complied, the regulated things you haven't, well, ultimately, it'll be determined by a court. It will be extraordinarily expensive and take years. So that is not how we're going to have to do this. If you think about the legal system, you'll all be broadly aware of the fact that ultimately the court decides. We don't have the time or the money for the court to decide. There are so many questions. So it will be in communities like this, market practice, standards bodies, people producing papers. I think Nick has picked on Bill and I because we're the lawyers that think you're building the tools that address the problems that this type of regulation is trying to fix. So it's well known that we've got an online misinformation, disinformation problem of enormous proportions. And I'm struck by listening to other presentations in the room that you guys are sort of working towards federated learning in principle and what you're building specifically in practice. Exactly these questions. Bill's calling out what we call data minimization. So not using more data than you need to. The consent issue is around people's data only being used for purposes that they are familiar with. So purposes is a big theme around this and the data regulation, data protection regulation that the European Commission is interested in. I think the other thing that's going to sit behind it as well is I spend a lot of time these days on ethical AI, trying to understand what that means. So that is somewhat answering the question here. If you're building with a view to ethics and the user, customer, data subjects experience, the likelihood is you won't go too far wrong. And so we're building themes and adding detail to those around the ethical questions. So it's ensuring that folks like you don't need to be lawyers, but have got access to people like us and enough knowledge of what the policymakers are trying to do. So when you're building systems, you can recognize the sales opportunity because it's fixing an open question that's sitting out there. You're driving it at themes that the policymakers themselves have got.
Excuse me. I think perhaps we should get the other question here.
Yeah, hi guys. Like Nick mentioned, I work in a quite highly regulated financial industry, and if I propose federated learning at work, my privacy team says to me, are we allowed to do federated learning? What is the rules and regulations? So they're asking me, but I'm not an expert on regulation. I can build a federated model. Is there any regulation I can point them towards?
So shall I take this? The point that Bill makes about this regulation sits horizontally across the regulation that's industry specific and sits vertically. So you've got financial regulation, as you're aware, in relation to, in these areas, things connected to data protection. So if you're using data connected to an individual, then you need to be concerned about it. If you're using data that's not connected to individuals, then you've got more scope in relation to that. So depending on the nature of the financial services that you're in, if it is insurance, then you have a lot of you have a lot of personal data. So you're aware of that. And sitting behind that in insurance, this may not be widely known, but the same regulators that are building this kind of regulation are also saying we can't have the modeling too tuned because we're then importing biases. And the classic one in relation to insurance is between male and female drivers. So there are limits in, the regulators limit the ability of insurers to simply price risk in premiums. So to come back to your question, you're overlaying the rules here, financial regulation, and data protection. The federated learning is, I think, not a widely known topic. It is not something that the financial regulators, I think, have got a broad view on. So your ability to persuade your colleagues is somewhat dependent on your ability to persuade the regulator. They are open to this. There are sandboxes in the financial regulators in every jurisdiction. So I think one of the things I was going to say here is as a group here, we need to work together with people like Bill and I, giving signposts and also looping in the other people that can enable you to build these things out. But it won't radically change what you're able to do other than in relation to topics where you're able to use data which is not identifiable to individuals. So if the systems that people have got in this room are adapting data to remove identifiability, then that's the thing that you're taking to your regulator and saying, hey, we're actually able to use data that we might have thought we couldn't because we can put it through these systems.
I just want to check if there's questions online. Pan, is there anything there? We've neglected them a little bit in the last couple of minutes. No? Okay. There's the guy with the microphone right now.
Hi, so I'm from healthcare. And recently, and especially post-COVID, there's been this conflict between the secure environment system on federal or national level, especially for health data, and then the other side of the coin where we have federated learning, secure aggregation, and then on the regulatory side, we have the AI Act, European Health Data Space, that's also in the works. And my question is, as a medical doctor and as a researcher, I would like to have data not only from the point of care, from the hospital, from primary care, but also data from the patient outside of the system. What are their daily habits? How much are they doing in terms of physical activity? Are they taking their prescription drugs? So in this balance of the taking advantage of the unfair data distribution of FL, but also the needs and the wants of governments and regional governments what do you think that in the coming years will come out of AI Act and other regulations?
I'll give a quick answer and give time to Bill. I think it has to come at a policy level. So I've worked with the UK Parliament since 2016, and through that time we've had some AI with medical data use cases that have caused concern in the wider population. So maybe repeating a little bit what I was saying before, federated learning, I think, is to a large extent the answer to that, and it is at a national level, because you'll hear some policymakers say that in the UK, where we have this sort of free at the point of delivery medical services, the one thing that people could use to pay for is their data. So if they're not contributing financially, they can contribute data, and that can be anonymized and managed in a very careful way. One of the difficulties that's often associated with it, and you'll know this for sure, you know what I'm talking about without naming names, large tech companies often sit behind the projects, and it becomes impossible to get through to the substance of it. It's drowned out in concern that's driven around the sort of the wider community connected to that name. So federated learning will take us away from that, and that's the direction that may make these things a bit easier to go forward with.
Briefly, Bill, do you want to add anything to that?
I don't have anything to add. Thank you, Charles. Really interesting question.
Well, actually, we were bang on time. So it just flew by. But that was great. I think we started to start a conversation in terms of understanding when the regulation comes, what are we going to do in terms of how we deploy models, how we research the field, and so on, because we will have to materially change. And the question will be, what tools will we use to navigate that situation? So I just want to say,
I'll make a final point just to say,
okay.
My point is very practical. You know who I am, because there I am. But I don't know who you are. So if you could connect via LinkedIn or whatever way you would, I'd really like to follow what you're doing, and to the extent I can help and support and bring lawyers. And not all lawyers tell you what you can't do. Some tell you what you can do. So find one of those.
My final remark, the paper that I mentioned was done in cooperation with IBM and TUM, Technical University of Munich, so please check that out if you can.
Those are two excellent last points, so thank you so much. Thank you.
Thank you.
So that ends session 2. We're going to have roughly a 20-minute break. There'll be the countdown timer. Come back then for the last session. Enjoy the refreshments.
Thank you. Oh, thank you. It's hard for a lawyer to talk to mathematicians.
to start session 3. Session 3 is starting. Let's get back. Okay. Session 3 is about to get underway. Yeah, let's okay. So for session 3, we're going to kick things off with another flower announcement. And so we're going to announce what we're calling batch 2 of our pilot program. The pilot program for Flower is all about accelerating the progress we're making in federated learning, and we can do that in a variety of ways. This particular program has been running for over a year now, and I want to begin though by say, as I start to unroll and describe what the pilot program is all about, start thinking about if you might be a good fit. Start thinking about, oh yes, I'd like to participate in this, and if this is the case, then go to our website here, flower.ai/pilot. There's a great QR code here that you can use to go to that site, and it'll take you to a page that describes all the details about the pilot program. So take a look. The pilot program is a way that we start to collaborate very closely with organizations and individuals who are serious about seeing federated learning and a variety of related technologies deployed, and who want to also help us make the framework and the software even better. And so in the past 12 months, we've worked with a number of organizations, and I want to give you a few examples. And so we can start to, after 1 year, we can start to tell you a few success stories. One example, a success story from batch 1 of the pilot program is our collaboration with Brave. So Brave was very interested, of course, in being able to maintain strong user privacy, but also being able to provide good user experiences. And some of those user experiences in the domain of advertising require user data. And so something that we worked with them on is how we could enable a Flower client to run in a lightweight fashion within a browser. And so as a consequence now, we have really good Chromium support for the Flower node, and this is an outcome of a pilot program. Another illustrative pilot program is with a group of medical researchers in the US. They have this incredibly ambitious project that they call the Human Anatomical Mapping Project. And so the whole idea here is that they want to be able to start to network medical images from a variety of hospitals towards building models that are not only just 2D but also three-dimensional, and so they can start to sort of move forward the prediction of a variety of illnesses. When we started working with them, they had a research paper, very strong piece of research, understood a lot of the fundamental issues, and then we've been able to migrate that piece of research to the point now that their system built on Flower can actually process real patient data. So this is another example of a pilot program success story. The final one is that you heard about it yesterday. So Gauchon University is one of the early partners in the pilot program, and they've built an extensive FedOps implementation on top of Flower that explores how we can do FedOps in a nice scalable way that users can really access. And so again, this is an outcome of our pilot program where we work with a partner. They've built a serious piece of tooling on top of Flower that enables a new functionality. So these are the types of things that have been successful. If you kind of generalize from those successes, you can start to see the types of examples that we think are canonical examples of people doing successful pilots. So you can have access, for example, to early features of Flower. Some of the exciting features of Flower that have been announced at FS24 this time around could have been in your hands months in advance if you're doing a pilot program with us. So then you could start to iterate with us, explain to us where there might be some areas of improvement in what we're trying to build. And so we really love these types of pilots because it allows us to release the feature to the community that's actually got somewhat hardened through actual usage at a limited scale. Point two is there are a lot of types of pilot programs that are really investigations. People have a machine learning problem. They think that they can use federated learning. Perhaps in some cases they didn't even know federated learning existed, but they had a machine learning problem that actually aligns very well with federated learning, and we help understand and unpack how federated learning can be applied in this case. So it's sort of really a question like, can Flower do X for them? And the final one is that we find people, organizations who want to build federated learning systems. They might be a champion inside their organization. They might want to build, for example, a privacy-preserving system, and they're attempting to do this, and they need some assistance. They might have the need of some technical expertise. They might need a particular feature of Flower. They might just need someone to help them move this forward in their organization. And we also love these, because these become illustrative lighthouse projects that other people in the community can then look towards, adopt, and perhaps borrow some of the methods that get built. So these are all great examples. Let's talk a little bit about the stages of a pilot program. One, you apply, you know the URL, you've seen the QR code, you can write an application that describes your situation. We find most pilots are unique. We'll follow up with your application with an interview. We try to understand you to see if there's a good match. And if there is, we sort of lean in proportionally to the impact of the project. So we're really looking for high-impact projects. People are very serious about getting something done in one of these areas. And then once we have an agreement, we start to execute. These projects commonly last for 6 months. And there's a definitive aim that we're going after, a particular goal that we jointly agree that should be reached. And after the project is finished, we launch it. And so that means that it means many things depending on the project. We might deliver that code that's an outcome of that project back to the community. They can start to benefit from it. It might be a technical report that describes to someone how something was done so they can then follow. It could be even just a blog post depending on the scale. So every pilot is unique from my experience, but they're all quite essential for us to be able to work together in a more structured fashion that is sometimes necessary when the outcomes are sort of more ambitious, and kind of where you go next requires a more tight collaboration. So that is the announcement for Batch 2. Batch 1 was so successful, we want to release at Flower AI Summit 2024 a call for Batch 2. Please apply if you're interested. We're delighted to talk to you. Thanks. So our next speaker is someone who perhaps could have been a pilot program, could have been a pilot project there, but they are folks from, sorry, I lost my train of thought. It's from the Vector Institute, of course. So I'm going to introduce David Emerson. He is working at the Vector Institute, and he and his colleagues have built a library called FL for Health. So FL for Health is a serious piece of kit that runs straight on top of Flower, and that really bridges the gap between the needs of various types of health-related partners that they've seen. There might be a need for the APIs to behave a bit differently. They found needs for certain types of algorithms and so on. They've bridged that gap, and then they're now enabling many sort of medical deployments in the Toronto and wider field to start to be realized. Let me tell you a bit about David as well. He's an applied scientist at the Vector Institute. He received his PhD in applied mathematics from Tufts. And I've got to tell you, I had some fantastic conversations with him leading up to this talk. He really understands the needs of a FL framework as well as the domain of medical deployments. So with that, I'd like to give the floor to David.
All right, cool. Can you hear me, Nick? All right?
Yes, sounds perfect.
Okay, great. I can hear you as well. So that's a good start. And yeah, so we would have certainly been interested in the pilot program. We've been developing this library strictly at this point as fans of Flower. So we are obviously very big advocates for what Flower is doing, and we've leveraged a ton of the different components of Flower and the flexibility that it offers. So certainly looking forward to deepening the collaboration with Flower going forward. So As Nick said, the library that I'm going to talk about today is FL for Health that we've been developing at the Vector Institute. The title is a bit sort of flashy and ambitious, but it reflects some of the goals that we're sort of trying to move towards with the library, enabling private and personal clinical modeling in collaboration with a number of hospitals in Toronto. So before I get started, I just want to acknowledge some other members of the team. On the left, the 6 names there are sort of the primary contributors within the Vector Institute. We also have a number of contributors through our collaborations with either various labs or different research groups. So I want to give a lot of credit to each of these team members. They've contributed quite significantly to the work. So I want to start with like the mission and design of the library, which I think probably dovetails fairly well with Flower in general. But the idea is to make FL research and deployment easier, more robust, and reproducible, with a specific focus on healthcare and clinical models, obviously in our case. We have sort of 3 design principles that we've been trying to follow in creating the library and all of the sort of touch points within it. We obviously want it to be an open source research grade platform with fairly straightforward and composable modules. Again, that's a very similar design ethos to what Flower is doing under the hood. We want to facilitate true federated learning training and evaluation at clinical institutions, which we all know is really hard because there are a lot of regulations, there's a lot of privacy concerns. And so we want to design the library to help make that easier. And then finally, we want to require minimal component definitions to use state-of-the-art techniques, because if we're going to solve sort of personalized clinical modeling problems, using state-of-the-art techniques, as we've heard from a lot of the talks in the previous day and this morning, I suppose this afternoon for everyone in person, you need to use state-of-the-art techniques to deal with all of the different challenges that we've discussed throughout the summit. Another set of things that I want to go over is the framework assumptions. So obviously there are a lot of different forms of FL. They've been touched on sort of throughout the summit. Specifically for us, we are focused on horizontal and cross-silo federated learning. I'm sure a lot of people are fairly familiar with these definitions, but in general, this means that the feature spaces are aligned or will be, assuming that you can do that in a federated setting or sort of with pre-work. But we're primarily concerned with expanding the data set size that we have for training. We also assume in this case there's a small or medium-sized pool of clients rather than say like thousands and thousands of participants in our training regime, which you would have in sort of like a phone federated learning setup versus these settings that we're looking at are things like hospitals or clinical institutions. We also have the luxury of assuming that there's at least a reasonable or large compute on each of the clients. We don't have to do sort of edge processing in our case, and that these clients tend to have like a reasonable data set size. They're not like 2 or 3 training examples each. And then finally, that they are reliable participants when called upon in the training process. So in the cross-device setting, you have people dropping in and out, they turn off their phones. For us, we're assuming that our participants are very willing to be a part of the process, and if called upon by the server, they will participate. Lastly, and it's sort of hinted at in the title of the talk, is that personalization and privacy are important. So heterogeneity is common in hospital data sets when they use different devices or have different patient populations, and site performance is really critical. And then finally, data assumed to be really sensitive. So obviously, we've talked about that a lot throughout the summit as well. So I want to start by highlighting some of the sort of major components that we've worked to implement in hopefully a fairly straightforward way across the library. I won't go through everything in a lot of detail, but we have a lot of optimization strategies. Some of them are built right into Flower, like FedAv, Average, and FedOpt. But a number of them require sort of complex processing or complex exchange of information. And so we've attempted to implement optimization strategies in a really straightforward way. I'm going to try and do a little sort of code demo to give you an idea as to how that works for us. Obviously, privacy-preserving techniques are really important and have been built right into the library and should be fairly straightforward to use. Communication efficient, FL, things like partial weight exchange, which is really important in personalization, but other things like compression of parameter exchange and that sort of thing are inside the library. Federated feature processing, I know there have been a couple of questions on that. So federated feature alignment is a really important thing if you're using tabular data to make sure that everyone is agreed upon the sort of data that's going to be used, and automated ways to sort of force agreement or induce agreement are built into the library. Other components that you might want to do as part of a pre-processing pipeline, especially for clinical tasks, like dimensionality reduction and synthetic data generation are also available. And then there's a number of sort of miscellaneous and interesting things that are built into the library, like things like federated checkpointing and sort of expanded probabilistic client sampling and that sort of thing. Cool. So just to touch on some results that we've used the library to gather so far in collaboration with Gemini, which I'll talk about in a little bit. We've done some clinical benchmarking across a number of clinical tasks. The results you see here are for the Flamby data set. Some people might be familiar with that, but it's an open source clinical collection of tasks, or collection of clinical tasks, excuse me, 3 of which are displayed here. So Fed heart disease, Fed IXI, and Fed ISIC. And using the library, we're able to really quickly benchmark across a lot of different federated learning methods to see sort of the benefits of FL in this setting. And you can see the bottom sort of rows here are personalized models. You can see that the personalized models, the bolded components and the underlying components, are really improving upon sort of the local training and the centralized training even when you include personalization for the tasks involved here. So those are interesting. They're open source benchmarks, and it's really important to show federated learning performs well for those. But we've also been working with real clinical data in the form of the Gemini Consortium. They collect data from over 30 hospitals in Toronto and beyond. And this facilitates sort of a really rich proving ground for federated learning tasks on real clinical applications. So for instance, on the left-hand side are results for mortality prediction, so predicting whether a patient will experience a mortality event within the hospital, and based on their sort of labs and tests and what they've gone through in their journey at the hospital. And then delirium development. So delirium is obviously a very serious development in clinical settings, and it is preventable if you are able to identify it fairly early. And so identifying delirium development as a risk is really important. And again, we see sort of a very large collection of FL techniques brought to bear on these tasks. And you can see that, again, personalized models are producing sort of state-of-the-art, in this case, accuracy and AUC ROC for both the mortality and the delirium task over what these hospitals could have achieved sort of independently if they train models themselves. Cool. So as I mentioned, the design of the library is meant to make doing this type of benchmarking, especially in clinical settings, fairly straightforward. So I want to give you a bit of a flavor as to how easy, in our opinion, doing something like this is for these applications. So assuming nothing has gone horribly wrong, hopefully you can see my code here. And Nick, please interrupt me if that is not the case, so I'm not just talking to the air. But in this particular set of code, those of you who are familiar with how you set up the sort of flower, typical flower run and frameworks to do federated learning, you design or you define a server.py file and a client.py file. And each of those defines how the server and the clients are going to behave together. So this is an example of implementing scaffold which, if you're familiar with the method, is quite a sophisticated method for non-heterogeneous data sets. It's a centralized or a global FL approach, but it requires the exchange of a lot of different information above and beyond just the model weights. And orchestrating that can be sort of very tricky, especially in settings where the model is sort of very complicated with different types of layers and frozen components. And so in this case, I want to show you how you might bring up your own scaffold method within the library itself. So there's some boilerplate that obviously Flower uses, like the fit configs. There's a definition of a strategy, the client sampling strategy, and then a server. In our case, in order to get a scaffold application running for your particular use case, you just define a scaffold strategy with all of the sort of same stuff that you might define a strategy in Flower. You also have to send over the model for it to take out some information that it needs from the model. And then you also have to instantiate a scaffold server. You just give it the same sort of information that you typically give a server in Flower, perhaps with a little bit of additional information. For this case, we're doing a warm start for scaffold. And that's it. You can sort of kick off your server as you would any other Flower application. And it will, handle the exchange of information in the server, the scaffold strategy right out of the gate. Similarly, on the client side, there's a couple of extra things that you need to do. Your client is going to need to inherit from a scaffold client, and you're going to need to define a couple of sort of integral components for the definition of what the client is going to do on its side. You need to define some data loaders for your train and validation loaders. In this case, we're just doing like a Dirichlet sample, a subsampled MNIST task. We need to define our optimizer, the loss function that's going to be optimized, and then finally the model that we're going to be optimizing. And that's it. The stuff that's sort of buried under the hood in the scaffold client will handle the exchange of all of the information that the clients and servers need to exchange in order to do a scaffold train. The rest is sort of the same as how Flower runs. I'll do one more example here, just to show how you can implement some really sophisticated methods. So I'll start with Ditto. Some of you may be familiar with Ditto. I'm just going to move this toolbar from working with FL runs. For Ditto, actually, nothing has to change for us on the server side. You just define the same stuff that you would define for a regular federated average training session from the server's perspective, and you sort of move from there. Everything, sort of the heavy lifting, is on the client side for Ditto. Ditto trains both a global and a local model and uses the global model to regularize the local model training. You just need to inherit from a Ditto client. You need to define the stuff that we talked about earlier, like a data loader, a model, and a loss function to optimize. And then the only real difference between the example I showed you for scaffold and Ditto is that Ditto needs two optimizers, one to optimize the global model and one to optimize the local model. As long as you define those and you map them to the global and local models appropriately, you're off and running and a Ditto model can be trained. And don't worry, we'll sort of warn you very heavy-handedly that you didn't define two optimizers under the hood if you forget to do so and try and use a Ditto client. There's also maybe one last example I'll show, which is just around partial weight exchange. So for FedPer, it's a personalized method that just exchanges components of the model. And so for FedPer, everything actually is the same, again, on the server side, except for you define a special FedPer model in order to make sure that it exchanges the right weights for initialization. And then on the client side, you define the components that we already talked about, the data loader, the optimizer, the loss function. But you instantiate a special model called a FedPer model, which defines what layers are going to be local and what layers are going to be exchanged with the global model. And the last thing you do is you say, okay, you override the full model parameter exchanger that's the default in our library, and you just say, I want to use a fixed layer exchanger, and these are the weights, or these are the layers that I want to exchange as defined by the FedPer model. Okay, great. So that's sort of the end of some of the examples I wanted to cover here. The last thing I want to do is just highlight some of our collaborations that we're working on now. We have a collaboration with the Hayter Lab at Mount Sinai Hospital here in Toronto, looking into the efficacy of FL methods for, this acronym stands for clinically significant prostate cancer detection and segmentation. The question is, can the use of multiple hospital data sets through federated learning reduce false positive rates and also known radiologist variance in estimating clinically significant prostate cancer in scans? We're also working with Jihe's privacy group at the University of Waterloo to improve the utility of differentially private clinical models trained with FL under strong threat models, meaning that the server may be sort of able to manipulate or inspect the model weights and do something nefarious with it. And this is working with clinical data sourced from several hospitals in Toronto. I've obviously highlighted some of our work with the Gemini Consortium. We're continuing to do a lot of work in this area because the consortium is a rich proving ground for FL methods. And then finally, as I mentioned at the beginning of the talk, as a group, we're really big Flower fans, but we want to sort of expand our collaboration. So we're really thankful for the invitation to come and speak here. And we're hoping to participate in future programs going forward to collaborate and expand on the offerings within Flower itself. Great, so I left a repository link at the top of this slide if anyone's interested in checking out the library itself. And I'll finish there and leave it for questions, if any are out there.
Thank you so much. Let's start with taking questions online. So Pan, is there any questions from people perhaps? No? Okay, that's cool. How about in the room? I know there must be quite a few. Yes? Yeah.
Hello, thank you very much for the presentation. I have a question. If there is, let's say, a new baseline that is put into Flower, how long does it take to bring it to FL for health, or how is the process, more or less?
That's a great question. So the process right now is fairly manual. So we've been trying to identify promising baselines either through their implementation within Flower or externally through our own personal research. And so we transfer them directly into our system. The Flower baselines are super helpful if someone puts them in there because we can see some of the inner workings of the code and it's very sort of highly polished, which makes our job sort of abstracting away the pipeline and components and communication into our library much easier. One of the things that we might be working more closely with Flower, and Nick and I have discussed this, is how do we streamline that process? How do we figure out a way to make that either more automated or an easier thing rather than us just sort of picking up promising approaches? But that's a great question. So right now it's fairly manual.
Okay, thank you.
More questions? Right here.
Yeah, so thanks for the presentation. Just in general, in federated setup, like how many hyperparameter maybe combination have you tested, or you fixed from the first one and then like just for the method, or yeah, just can you make any comment regarding the hyperparameters?
Yeah, sure. I'll put up these. I assume these are the sort of hyperparameter tuning results that you're referring to. Correct me if I'm wrong. But in both of these cases, we did some extensive hyperparameter tuning, especially for models approaches where a lot of hyperparameters are necessary. So, for example, PerFCL actually has sort of 3 major parameters that you need to tune. And so we went through sort of an extensive search for this particular approach in order to determine what the sort of best settings of the hyperparameters are. And one of the sort of benefits of the library is that we've sort of built in checkpointing and loss aggregation and reporting into the library itself so that we can easily take measurements on the validation set and give sort of the best hyperparameter combination that's experienced through those searches. I don't think we knew about, at least personally, I didn't, the new additions of the hyperparameter tuning within Flower. So we might actually be able to integrate more tightly with that as well. But some of the other methods, federated averaging, only really needs the tuning of the client-side learning rate. But others like Ditto, for instance, requires tuning of the parameter associated with the global versus local model constraints. So I don't have a slide with all of the hyperparameters tuned, but if you go to the library, there's like a little archive link within the README that you can go and you can actually look into the hyperparameters that we tuned for each of these methods to get these results.
Thank you. Cool. Other questions? We have time for a quick one. There is. Here comes one.
Hello. Thank you for the presentation. Just two quick questions. As someone that also works with medical imaging data, so kind of a similar setup to what you're showing us. So the first one is, how did you deal with the fact that these different aggregation strategies might require different hyperparameters when trying to compare them fairly to each other? And the second one is if you have a current favorite that you would say is worth the trouble over federated averaging.
Sure, yeah. So for the first one, I think the previous question got to that a little bit, which is to say that for each of these, we tried to tune across the sort of most important parameters associated with the models themselves. So again, just to expand upon that a little bit, like FedProx has a parameter with the client learning rate, which most of these models will have a hyperparameter associated with the client learning rate. But in addition, it has its classic proximal term, the mu value, if you're familiar with it. And so we tuned across that one as well because it's the sort of most important piece in controlling heterogeneous learning and that sort of thing. So in each of these, we did a fairly extensive hyperparameter sweep for all of the methods in the components that we sort of identified as most important. So that's the major one that we did in both of these studies to control for hyperparameter sort of dependencies within the methods. In the second one, I think what these results sort of strongly highlight is that personalized methods for these particular applications are all fairly strong. I think the two that have been identified here that we think are sort of consistently strong and offer really high-performing results are Ditto and FendFL. You can see here that FendFL is the sort of best performing, second best performing model for these two, and then Ditto is a fairly strong performing model for FedIXI, the strongest for FedISIC, and then the strongest for mortality here, where again for delirium, Fenda has a really strong AUC ROC, if that's what you care about, and a very competitive accuracy. So I think those are both really great. We also had a really nice talk earlier about MRMTL, which is fairly related to Ditto and FedProx. So I'm actually really excited to go back and implement that because I think we can do that in a day in our library really quickly and do some experimentation. And so I'm sort of excited to try out some of the methods that we heard about in the talks yesterday.
Great.
Thanks for the question.
Well, that's all the time we have for questions. Let's thanks David again. Thank you so much for all the work that you've done. Our next speaker is going to talk to us about a very important topic, about how do you do portable and reproducible deep learning work in the domain of Flower and a very popular ecosystem called Conda. So it's my pleasure to introduce Valerio Maggio. I'll just move to one side so you can sit up. And so he is talking today on behalf of the Conda open source ecosystem. He has most recently also been a senior RA at Bristol, where he did research there. And he holds a PhD where he's actually very passionate about privacy and machine learning. And you can, if you check out YouTube, you'll see many talks from him on this subject matter. So we're really fortunate to have him speaking here today. So thank you.
Thank you very much. Can you hear me? Right. Okay. Thank you very much, Nick, for the introduction and for the invite. Actually, I have a slide to quickly introduce myself. How I call this slide is normally a short introduction of me in logos. As Nick said, I have a background in computer science. I did a PhD in machine learning. I've been working at the University of Bristol as SRA. I'm actually fellow of the Software Sustainability Institute. And this is where actually I got my interest in previously preserving machine learning. I'm also very much involved into the Python community. I've been organizing many events throughout the years, like 15 years now, like PyCon Italy, EuroPython, EuroSAPI, you might have heard some of them. And now I do work as a developer advocate, and today I'm going to be speaking about the wonderful job the folks in the Conda community have done. And I actually want to start with a question to all the folks in the room. How many of you use Conda for their data science or machine learning environments? All right, so more or less for those on the internet, more or less half the room, shall we say that? That's exactly what I was expecting. And for those of you not familiar with Conda, essentially Conda is started as the name of the tool, but Conda is actually more a community. And throughout the year, the name is actually referring to an entire open source packaging ecosystem and philosophy. These ecosystem is actually supported by many organizations nowadays, and these organizations share the same goal of providing easier access to programming tools and libraries. So conda.org is the reference website, and within these initiatives, it does exist Conda Forge. Conda Forge is indeed the community-led recipes, infrastructure, and distributions for Conda. And you can have briefly look at the statistics this website has. So just like monthly download, we have 134 million. Just to give you a little bit of statistics about what we're talking about. And why I'm mentioning this, because recently announcement, and you can find this on Charles' blog post on flower.ai/blog, Flower is now available as a Conda package on Conda Forge. So if you're using Conda as your development environment, you can install Flower directly from the Conda Forge repository. So going back a little bit to what we were talking about, so portable and reproducible deep learning environments. I'm going to focus very briefly on what I mean by deep learning environment and by using a very foundational deep learning environment. So normally what you want to have, well, of course you want Python. So you have, for example, Python 3.11. And we're going to install in this environment a few other common packages like Jupyter or IPython. Of course, we can have our deep learning of choice. I'm going to go for PyTorch, because that's my favorite nowadays. So you can have PyTorch and Torch Vision, for example. PyTorch has dependency with NumPy, so you also get NumPy. And, of course, Flower. So we're going to consider this as the reference deep learning environments. The Conda way to create this environment is you fire up your terminal, command line, and you do Conda create. -n is the option for the environment. We're going to have lots of creativity. I call it GL environment. And then you can list the list of packages you wanted. And if you run this one, essentially what you're going to get is an environment containing the list of packages. You may notice that what I did when I installed this environment, I actually specify the version only to the Python version. The rest of it is essentially taking the latest release. And this is essentially how we normally start with things, unless we have specific requirements. So you get started with this environment, this is exactly what you get. Interestingly enough, though, why I'm trying to explain why I'm talking about this today. Essentially, when you why specifically deep learning? Well, deep learning is a very interesting use case. Certainly, you have different development stages. So imagine that you have this environment, and you want to, first off, have the very same environment on prototyping stage. So we're talking laptop. Let's say we have a Mac OS laptop. And then we want to use this environment for training of the model. And maybe we want to go to a Linux server, so it's a different operating system, and also different architecture. And also the packages for deep learning, we want to use GPU. And what about inference? We want to move to a server, which is, for example, I don't know, AWS Graviton, even another target architecture. So what we really want to do is, first off, we want to have an environment which is easy to install on every single platform we need. And that's exactly the portability we're talking about. So we want to recreate this environment easily on multiple platforms. And by platform, I mean any combination of operating system or hardware architecture. So for example, what we've been considering OS X 64 as the laptop, OS X ARM 64 as the inference server, and Linux 64 as the training server. But at the same time, we want to make this reproducible because, for example, to guarantee reproducibility, we want that each specific versions of library in each of the supported platform is going to be the same. So for example, if we're going to training PyTorch on Linux server, we want to have PyTorch with CUDA, and we want to specify the version of CUDA we're using, like 11.8. If we're going to the inference server, we're going to have PyTorch with MPS backend support. If you're going to laptop, we want to have PyTorch with CPU support, and maybe if we have Intel CPU, we can have MKL acceleration on those. So as you can see, one single package has many flavors, depending on what is the target architecture. But we don't want to, we essentially need to have a method to seamlessly support multiple platforms and guarantee full reproducibility. So in Conda, normally what you do, well, the first thing you could do is like Conda env, if you want to export an environment into a file, the so-called environment.yaml file, and for those not familiar with this format, the file you're looking at is in YAML file format. So if we do something like that, it, of course, it's portable because that's how Conda was designed in the beginning. So you want to easily recreate the multiple environments on multiple platforms, but certainly it's not reproducible. Well, of course, we don't have any version number, so this is not going to work anyway. We can do something better, still using Conda, and we can do Conda env export and remove the builds number from packages. This is fairly technical, but this is a very good best practice because normally the build number is going to change depending on the platform, and is not really interesting if you move into multiple. It doesn't really gonna matter if you move on multiple platforms. But if you do something like that, you do have an export of the entire environment. So lots of packages we never installed explicitly. So it's certainly not easy to handle. And so perhaps this would be a better representation of the environment or YAML file. So we could get the previous result, manually modify that, and so at least we have the list of packages we originally installed with the version numbers. And this is a starting point. This is a very good starting point, but still we have a problem. How do we handle the case of having PyTorch installed with different flavors on multiple platforms? So where's the CUDA Linux on Linux machine here? And so I want to introduce, in case you're not familiar with this, I want to introduce a fantastic tool the Conda community has developed. It's called CondaLock. CondaLock is essentially a lightweight library that can be used to generate fully reproducible log files for Conda. So starting from an environment.yaml file, what you can do is, so you have CondaLock, you pass in the environment file, and then you specify what are the platform you want to target. So in this case, we want to target from this environment the platform of the laptop, OS X 64, and the platform from the inference server, OS ARM 64. These are the two platforms that don't require CUDA and GPU support for PyTorch. If we want to include also a target for a new platform, say Linux 64, we could do something like within the same session, we can run this command afterwards, like including Linux 64 of the platform, and include the option ---- with CUDA and the version of CUDA. Why we do that? Because of course we have Linux, so we can have everything we wanted. We can have PyTorch with CPU on Linux and GPU. In this particular case, with one GPU. So the result of these two commands is a conda log file, normally named condalog.yaml. And as you can see, this is just an extract. As you can see in this log file, this is just a snapshot for Platform 64 and PyTorch. I'm sorry it's not entirely readable, but what you would read there is like you have the name of the package PyTorch with CUDA installed there. So for Linux 64, in this log file, you have the PyTorch with CUDA support. And actually, if you look at more carefully, you have, for the laptop, you have PyTorch with CPU and MKL. Sorry if that's not readable in the back, but trust me. For Linux, you have PyTorch CUDA. And you can immediately see that the dependencies these two packages have are very different because they have different dependencies. And OS ARM 64 has a CPU generic, which means MPS backend. The main advantage of doing conda log files, apart from being fully reproducible, is that log files contain directly the URLs of each packages, meaning that whenever you're going to replicate and reproduce this environment, you don't have to do resolving of the environment at all. It's just like downloading the packages and that's it. It works immediately. All the environment has been resolved already for you. And in fact, if you want to use it, to reproduce the environment, you do conda log install, you pass in the prefix of the platform you want, and then the name of the conda log file you're using. And if you make it portable, you can even generate from the same conda log files, you can generate the rendering of the environment for specific platforms. So like conda log render, -b Linux 64, it generates your new log files specifically for the Linux 64 in case you don't want to have everything within the same file. And that's all I have. Thank you very much for your kind attention. I will be posting the slides on Conda Incubator, which is the repository of conda.org where all the resources about Conda are being posted. And I'm hoping for any question if you have any. Thank you very much.
Thank you. We have time for a few questions. So questions online, perhaps? We're looking. Let's take an in-the-room question if we see one. Yes, the gentleman down there.
So I'm just curious how long the package is actually kept in a Conda community, for example. Like, I mean, there's a version like 2.0 and then 2.2, blah, 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 and then maybe the old version is going to be maybe deleted, right?
Yes.
And then my further question is, if that's deleted, like in this case, maybe one of the package is kind of outdated and then maybe it's caused some error, right? Then in the end, actually have to maybe manually fix the conflicts on packages. So it's also like discussed about like this type of...
Yeah, that's an excellent question. So the reason why CondaForge exists is because essentially the people working on CondaForge, they make sure that all the dependencies are guaranteed for all the packages that are there. So whenever you're getting any package from CondaForge, you're absolutely sure that all the dependency will be resolved. So the package is going to work. In terms of maintenance, so in long term with different versions, it really depends on what is, well, first off, it depends on what is the support that each package has, like by themselves. So like if anyone is willing to take on the responsibility to maintain any package, it's really community driven. So it's really a community effort, getting the best effort to maintain a specific package. Normally, every package in CondaForge undergoes a very thorough process. So like before getting onto CondaForge, which is really the community reference recipe and repository of packages, you have to guarantee that the package is maintained, and then there's a full ecosystem around it. Otherwise, normally what you can do otherwise is like every single user can have their own channels, and then you create, I think this is hosted on a Conda platform though, you can have your own channel and you can maintain your own package. So you're free to do that without, and people can install packages directly from your channel. When you install packages using Conda, you have this option of using different channels, and CondaForge happen to be the community one, but you can customize as many as you like.
Thank you.
Great. Any questions online? Perhaps not.
There's one there.
One there. Just let's keep it brief.
Thanks. Actually, I have a question. After every installation of a package, Conda becomes more slower and slower and slower. So is there any way we can increase the speed, or is how?
Yes, that's also a very good question. So Conda has been, so the slow part of is not actually the installation, is the environment resolving. So because whenever you need to install a package, what Conda tries to do, and I essentially briefly mentioned this in the beginning, so when you want to install packages, you have to resolve a long list of dependencies. And so that's what normally takes time. Although now Conda has changed the engine in the backend, so it's not using the old engine, it's using a new engine based on Mamba, and that is again a community effort, like joining forces together. Conda and Mamba community, essentially they are part of the same community. And now if the Mamba solver is default in Conda. So even if you resolve a package, it's pretty fast. But another reason why you want to do, once you've done all the resolving packages job, if you use Conda lock, you don't have to pass this step anymore because the package is already there. So the log files is not like a list of names of file, it's a list of dependencies with specific URLs to each packages. So you just download it and install it. So that's it. That's another reason why you want to use Conda lock.
Okay, that's all the time we have, but thank you so much. Great talk, love it. So our final technical talk of FS24 is going to be given by Mina Ali-Begili.
Yeah.
Great. I've known her for many years, but I can never get that last name at all. She is an AI researcher in Zenzac, which is a subsidiary of Volvo Cars. There she leads a number of technical innovations, really. And what I really love about some of the work she's been doing is she fundamentally understands the importance of data sets and moving the community forward. And so she released an amazing data set at CVPR this year that we hope to eventually have available in Flower data sets. But the work that she's been telling you about is, I think, some really important work in how AI can impact something we do every day, that of driving and a bunch of other types of medical ML tasks as well. So over to her.
Yeah, thanks a lot. Okay, yeah, the screen is working. Hi, everyone. Great to see you all here. So thanks for the introduction, Nick. So today I want first to discuss Zenzac Open Dataset, and after that I will talk briefly about a few applications of Federated Learning that uses Zod and Flower as well. So let's get started with the big picture. So as you know, the high number of fatal accidents and severe injuries is a big problem in our society. And notably, most of these tragedies are due to human mistakes, like 94% of those tragedies. And this is something that technologies like autonomous driving can reduce these numbers significantly. But what is needed is a larger scale and comprehensive data from real-world driving, which is something that not everyone can afford or have access to, which means that basically it hinders the development of autonomous driving and consequently road safety in general. So at Zenzac, we decided to basically share part of our data for public use to encourage collaborations and joint efforts to improve the road safety and advancement in autonomous driving. We call this dataset Zenzac Open Dataset, or ZOD for short. But maybe you wonder, okay, what is this dataset about? So this is a larger scale multimodal dataset, which is collected over 2 years in different European countries. And it's basically much larger than other available AD datasets. And beside that, basically it has highest resolution and highest range sensors. And also we cover highest diversity. I will talk about it later on. We also provide detailed multitask annotations for several perception tasks. And most importantly, we released this data set with a permissive license that allows both commercial use as well as research. And we come with a software development kit that facilitates the use of it. How we collected this data set? We used our developmental cars with the same sensor suite, each with a high-resolution camera, with long-range dense lidars, and also high-precision GNSS and IMU sensor. We also provide, in addition to these sensors, we also provide some vehicle data that might be applicable for some applications, as well as satellite positioning. Like a little bit more details about the data set. It's actually categorized into 3 subsets: frames, sequences, and drives, each targeting a different application. So what happened? Okay. Frames are basically single camera images that with 2 seconds of other supporting sensors. We also provide multitask keyframe annotations for those. Sequences cover 20 seconds of the full sensor data, and drives are similar but last for several minutes, like 1 to 6 minutes. And as seen here, and I mentioned briefly earlier, it has a high diversity. So we collected this data set in different road types, like highways, urban, rural, and such, under different weather conditions, foggy, snowy, cloudy, and so on, and under different times of the day, night, twilight, and so on. So it covers the highest diversity. We also provide, as I said, some multitask high-quality annotations, such as 2D, 3D bounding boxes for the static and dynamic objects, or instant segmentation for lanes, as well as traffic sign recognition. So please check out our website if you are interested to know more about this. And yeah, don't hesitate to contact us if you have any questions or want to have any contributions. We look forward to that. So by that, it was a very quick overview of Zod, but I think that was enough to understand the rest of the talk. So now I want to switch gear a little bit and talk about a few applications that are basically how we can use federated fleet learning for that uses Zod as its data set, and also Flower as its federated learning framework. But besides going dive into those projects, let's have a quick look at the high-level AD software stack. So it looks something like this, and basically the perception stack is a couple of like usual modules that run in an AD software stack. And most of these modules nowadays are deep learning based, which means that most of them are supervised and they need high quality annotations that are usually provided by skilled human annotators to be trained, right? One of these modules, as you saw before, is lane detection. And as I said, it's supervised and needs annotation. So assume we want to update this model in a federated fleet learning setting, which means using our customer data. Data cannot leave the car in that case, like our customer car, due to reasons that we are all familiar with, privacy and regulations and bandwidth limitation in our case as well. So the other challenge is that accessing skilled human annotators in the car is also challenging. So one potential enabler could be that we use other sensors in the car, such as high-definition maps that contain detailed information to kind of label the data and create 3D lane labels. So in a research project, we actually did that, and we used high-precision GNSS sensor. We localized the car. We used that information, query map around that position. And then we filter out just kept the relevant information, lane information, and then we project that back into the road coordinate. And then we end up with 3D lane labels, something like as you can see here. With having that, then basically we can train an end-to-end 3D lane detection model, something like this one, for instance. I will not go into details because of time, but we can discuss it later on. But then the inputs to this model will be the input images, and the outputs will be the 3D, the automatically generated 3D lane labels that we discussed. So then we did that, and we saw that basically by doing that, decentralized learning with fully automatic labeling can reach unpaired results with centralized training. And also we saw that it's not that far from actually decentralized learning that uses manual labels, not automatically generated labels, right? This is promising, that basically we can train such models despite being supervised in the car. But still we can make it more sustainable, because label generation in the car is non-trivial, and it requires a lot of resources, and while we have restricted resources in the car. So in another study, we looked into semi-supervised learning, and we actually trained model with extensive unlabeled data and very limited labeled data in the car. In that project, we focused on another components of AD perception stack called road segmentation, which basically says where the car can drive, where is drivable actually. And that one is also a supervised task. Okay. For that, we adopted an algorithm, maybe some of you are familiar with, fixed match seg, which is suitable for semantic segmentation task, and it basically works with a minimal number of labels, and then it uses an extensive set of unlabeled images and do different augmentations, and then do regularization and pseudo labeling, and then use that information to improve the performance of the model. From that project, we saw that federated semi-supervised learning can reach comparable results actually with centralized semi-supervised learning. And its result is not too far, as you can see in the top, it's not too far from that, which is a centralized supervised learning, which benefits from much more labels, like 50 times more labels. So we expect that by using more unlabeled data, perhaps we can shrink this gap even further. Yeah, and that was it. There are more applications, but I thought maybe this two is enough for now. And I have a news that now we have actually integrated Zensact Open Dataset with Flower and Hugging Face Dataset, which is great. Thanks a lot to Adam from Flower Dataset for the great help. And yeah, we hope with that we can facilitate federated fleet learning for vehicles, and yeah, at the end we can improve the road safety as a consequence. Yeah, thank you for listening.
That's amazing. Last time I talked to Adam, it hasn't been finished. That's how fast we move.
Actually do it during the talk.
They did it during the talk. Wow, that's incredible.
Yeah.
Any questions? Any questions?
It will be updated with more annotations also. But, yeah.
Great, great. Any questions? Oh yes, in the back there.
So in this setting, thanks for the
thank you.
Nice presentation. In this setting, the client is the car, each car, is that correct?
Yes, that's true.
And how does it transmit the information?
Actually, like we can, when the car is stable and connected to the charger, then you can use more like cable Wi-Fi, which is more stable than like 4G or 5G that is available in the car. But yeah, that's one of actually the challenges that, especially with, for instance, LiDAR data sets, which are really big, it's a big challenge that how to send the data out of the car, which is optimized, and at the center or wherever you can also, you know, retrieve it in a good way that you don't lose information. But if we can actually do the training in the car, then we don't need to send the data out, right? Then that's one of the biggest benefits, because then we save bandwidth, we save energy in the car, and so on. But of course, it comes with some trade-offs, and we need to have the compute available in the car and things like that. But when the car is stable, then the compute is not being used, right? Then why not using it for updating the model? Yeah.
Great. Any other questions? I just want this gentleman just here, just beat him.
Yeah, so I have questions. The number of the cars, like how many cars actually involved in this federated learning, and the second question is, you cover like multiple the countries. Then maybe each car, maybe one car is located in Spain and the other car is located in Sweden, or how was it looks like a little bit detail in your experiment?
Yeah, actually in the projects that I show you, it's not really larger scale, to be honest. It's like a limited number of cars, but they were from different geographies. For instance, in the 3D lane project that I showed you, it was 5 clients and from Norway, Sweden, and Germany. But we are working on another project that we want to basically make it much larger scale, really do it with the fleet scale that we can see. Yeah, then if you are interested about data partitioning and how we can use it like this data set, there are lots of metadata available, and also the information about the location and so on. And also the name of the cars and so on. So basically we can partition the data based on that. Yeah, we will soon implement that as well with Flower, but not yet.
Yeah, thank you.
Great. Let's thank Mina again. Thank you so much.
Thank you.
So that brings us to the end of Flower AI Summit 2024. Well, I just want to say thank you so much for all the energy that's been in the room the past 2 days. I want to thank the speakers, the poster presentations we saw, the attendees, and everyone who's been online. Thank you for joining us. It's been a fabulous event. I really want to say also, if you're interested in joining the Flower community and being a more active participant, please join us on Slack. It's the best way to connect with us. There's also Flower Discuss that's been announced. And really, we're looking forward to what we can do in the next 12 months. We've moved so fast in the past 12 months. I can't imagine what we can do in the next 12. But again, thank you so much for coming. It's been a real pleasure. Thank you.